until somebody told him to do something. And he stopped because he got bored. So like 3 weeks, he didn't do anything.
Wonderful.
All right, we are live streaming. Do you want me to?
Are we streaming?
Yeah,
Live?
I just double checked and it is actually streaming everything we're saying now.
Do
Awesome.
you want me to?
Okay. No,
what
no,
time
no.
do we officially start? 8?
We're starting in 3 minutes. So we're all good. Hello, everyone, if you're watching out there. This is us doing a checklist to make sure everything's working.
Yeah.
I don't see a stream. Where is it? Do I need to do a refresh?
Okay. Yeah. There you go.
This is 8KB online streaming.
Yeah, I think so.
That just takes me to our page.
Yeah, that's all it ever did.
Yeah,
I
and
put
then
the
it's
link.
live, and there are 5 people watching.
I don't see it.
It's everybody but you.
That's fine. As long as we are streaming, I don't mind.
Yep, can confirm.
Looks good. I see me.
Do I need to leave? I don't need to leave that up, do I, Mark? I can close that.
Yeah, but then there's a little button that says live.
Oh yeah, on home there's live. Yes, and then I see it now. Cool. Okay. You know, the
Computering is
attendees
hard.
list coming up. We got 2 more minutes. I won't share my screen. Actually, I'll share my screen once we get going.
Well, you can share the 8KB logo now. Otherwise, people are just going to be staring at our faces.
All right, fine. How's that?
Looks good.
Lovely,
Lovely.
lovely.
I was in Leeds for the not cricket, as you would call it, Rob, on Sunday. It was your bank holiday over here. And we had to leave halfway through the men's match because our flight was coming. Get to Leeds, our flight's delayed by 2 hours.
Oh,
Really?
no.
And Leeds Airport is something else. Ha!
Leeds
Yeah.
Bradford.
Yeah. It'd be good if it was ever cleaned.
Perfect.
Oh, it is 2 o'clock. We should start.
Is it really 2 o'clock though?
It's 2 p.m., 1 p.m. UTC. We are good to go. Press the button, man.
We're good. Go.
Oh, we're going. Oh, thank you. Thanks for telling me. Hello, everyone. Welcome to the 2024 edition of 8KB. It is absolutely fantastic to be back. As ever, we are such a professional organization. We have no idea what we're doing, but we are very, very pleased. This is actually the 5th edition of 8KB. So really, really good that we've managed to keep it going this long, and we have an absolutely fantastic lineup for you today. As always, 5 in-depth technical sessions from 5 amazing speakers. So we've just got some little bit of housekeeping before we kick off with Claudia's session in about 9 minutes. So the first one being, just to introduce ourselves. Sorry, Mark. There we go. 8KB is Mark Wilkinson, Anthony Nocentino, and myself. We've been running this since 2020. It really is a labor of love. Hi, chaps. How you doing? You all good?
I mean, if this hurricane would just get done with its business, I'd be a lot better.
They say we might lose Mark at some point due to his house being blown away, Wizard of Oz style.
Well, no one be alarmed. His house is not actually blown away.
No, just lots of flooding.
So that's us. Not going longer on that. And today's schedule. So we're going to kick off with Claudio in 8 minutes now with X-ray and schema operations, adding and removing columns. And after that, we have Jess Chapman with Azure SQL Database Business Continuity. Then keeping going, we got Deborah with Mining Statistics for Data Insights. Then Amy Abel with Navigating High Availability Challenges and Preventative Strategies for Split Brain. And then last, but certainly not least, we have our Janice with Black Box No More, going through some LLM internals. So really, really strong lineup. Actually, this year was probably one of the strongest lineups we've had, I think. The submissions we had were just absolutely fantastic. So when we were doing the session selection, it was a little bit more argumentative than usual. Would you say, chaps? Some strong opinions in there?
Yeah, there was a lot of good choices. Definitely a lot of good choices. A lot of ones I didn't want to say no to, but we didn't really want to stretch this into a 2-day event. So
no, absolutely. This is never going to be a 2-day event. My nerves just will not take it. But we've got fantastic stuff coming. We've got some housekeeping stuff for you here. We want to say thank you to our awesome moderators. These are their profile pictures that I've stolen off the internet in a completely non-creepy way in any way, shape, or form. They really do help us out. They will be helping us with the Q&A throughout the day. We've got Rob, Jess, Andy, and Matt. So thank you so much to them. They basically allow me, Mark, and Anthony to do nothing all day, which is fantastic. So we can sit back and watch the sessions. One thing we do want to mention as well, we have a code of conduct for this event. If you want to get more details of that, it is in the link at the bottom of the screen. But basically, it comes down to be excellent to each other. If you're not excellent to each other, well, we'll deal with that later. But 100%, we expect everyone to adhere to the code of conduct. Thank you very much. And as ever, we have a whole host of online resources for you. So over the GitHub, where the speakers will be uploading all the session materials to, so that'll be available for you. We are streaming this to YouTube, so we'll have immediately after the event, pretty much. We will have the whole thing recorded up on YouTube, and then when Anthony pulls his finger out and does some work, he will chop it all up, and we will get the individual sessions. Again, there's our website at 8kb.online with a whole bunch of stuff on there. If you're watching on YouTube and you want to join in, registration is going to stay open until the very last session, so you can jump in. The link will be sent to you, and you can jump into the Zoom session. Any issues at all, or if you have any feedback for us, there's our email address, info@8kb.online. And we very much encourage you to get involved in the SQL community Slack. We have a whole channel in there where we'll be hanging out all day, where we'll be posting basically what happened last year, we had a whole bunch of people jump in, posting links to technical blogs, talking about the technical content being discussed. There's a really good community in there, so we very much recommend jumping in there. And then finally, for each one of the speakers and the event as a whole, we have a whole bunch of feedback links at that link there, and we'll post that link at the end of each session. So please do leave feedback. We will forward that onto the speakers. Please keep it constructive. I once had a feedback from one of my sessions saying I didn't like it. The stage was squeaky. I mean, I don't really know what I'm supposed to do with that. So please keep it constructive. We do audit these. So anyway, but we will post a link to those at the end of every session, and then we will forward those onto the speakers. And of course, we will take on board any comments that you leave for the event as a whole. One thing we always like to bang on about, is that we have 0 sponsors whatsoever for this event. It really is a labor of love. We pay for this pretty much by selling t-shirts. So if you would like to support 8KB and buy one of our fantastic t-shirts, the link to our bonfire store is there. Every bit of profit that we get from selling those t-shirts goes straight back in to running this event and or Anthony's drinking habit. Anyway.
Man, I'm really getting it today. Jeez.
He is. Yeah.
Anyway, but yeah, there's the link there. And of course, I mentioned this, we have the SQL community Slack sign up. So if you click on that link there, it will take you there. You can sign up and jump in to the Slack, find the 8KB channel. We'll all be hanging out there all day, and you can interact with us. If you want to, you can ask questions in that channel if you prefix everything you say with question in capital, and we'll be polling that throughout the day, making sure that those questions get pushed on to the speaker. But we also have the Q&A option this year, Mark, in the
Can't
Zoom
win.
session where
He
you can
picks
use
on me
that
when
to
I
ask
don't
questions
turn
to
it
the
on. He
speakers.
picks on me when I do turn it on. Just
Are we recording? We are.
yeah,
Great. Good.
Oh man, open up that wound.
I know.
Just in case everybody wants to know, someone's about to go on leave for a couple of days, so he's a little extra punchy. If you couldn't tell.
Fair enough. Well, I should be on leave today, but guess what? I'm busy doing something.
You've mentioned it several times.
Yep, fair enough. Fair enough. I've completely lost where I was. So anyway, so there's the SQL community Slack sign up. How are we doing for time? Okay, we're okay. Right.
Yeah, we got 3
Okay,
minutes.
so coming up in no less than 3 minutes time, we have our first session with Claudio. So what I'm going to do is I'm going to stop sharing my screen, Claudio, and you can pull up your first slide and we will go from there.
Let's go. So, here we go.
Excellent stuff. Okay, so we'll give it a couple more minutes and let people filter in for the start of the first session, and then I'll kick you off. But yeah, looking forward to this one, man. You got demos coming up as well, I'm assuming?
One or two.
Absolutely fantastic. We've already got a question in here. Great. Cool. The link worked absolutely fine. Wonderful. Okay, so we've got the live stream. Everything's been recorded. We've got a load of participants in. We are pretty much good to go. We'll just give it a little bit more. I'm a stickler for time. And then we'll all mute ourselves and you can go for it there, Claudio. And yes, well, one thing that's just been pointed out to me is all those resources on the slide there, I will post into the 8KB channel in the SQL community Slack, so we can get all that. All right, Claudio, nearly good to go. Take it away, please.
Yeah. Okay. Thank you, Andrew. Thank you, 8KB, for another year and another online conference where we can try to share some more in-depth info. And today I will bring some X-raying schema operations, adding and removing columns. As some other sessions that I usually do, these appears related with some client questions and then my curiosity and go after some stuff and going on the rabbit hole and get a bunch of demos and then like to share and to spread the word with the others. So, but before we go, because this will be a demo session, it will be important to remind here what is a data page on SQL Server. And a data page is a 8KB page. So we have 8,192 bytes. Each one of these page, as we can see here, as this representation from Paul Randall. If you never heard or read something from Paul Randall, I encourage you to go on the website and see all the golden things that is there. So a page can be divided in this case with the page header that always occupies 96 bytes, which means that it will leave 8,096 bytes for records. And very important is to remember that one record on a single page cannot have more than 8,060 bytes. Why is this important for something about adding and removing columns? We will see in a second. So my name is Claudio Silva. Sorry, because the animations went over. And I work for Data Masterminds. My regular day-to-day is inside of SSMS and ADS and performance tuning ugly queries and try to make the things faster. When I'm not doing that, I'm doing some automation with PowerShell. I'm a proud open contributor of the open source projects DBA2 and DBHX. Yeah, and there is my contacts. I expect these demos will be uploaded for the 8KB GitHub, but you can also find it in my GitHub. So let's move to the interesting stuff. The first demo I want to give, well, let's start with adding columns. So adding a column was, and it is always a kind of online operation. What does that mean? It means that we can add a column and not blocking the entire table, because in this case, when allowing nulls, this is a kind of a metadata operation. So it's quite fast to be done. So for our demos, I will be using X-raying database. It's an empty database where I will be dropping and creating a table a bunch of times with different columns and different sizes and so on to show what I mean for each one. Here I'm running these demos on a Docker container. So I'm using a SQL 2022 on a Docker container. I have one enterprise and one standard because at some point we'll need to compare something. So let's start with creating a table where we have 3 columns: the ID, first name, and the date of birth. Then let's insert 50,000 records, and we can check that we have data there. So now let's see how much space this table right now occupies. And here we can see that we have our 50,000 records and how much is reserved, which is a sum between the data and the index, and how much is unused. So data pages that are allocated but not yet used. And to get rid of this unused space, just to tidy up the things in this specific case, let's do a rebuild. And if we check again, the 120 KBs, now it's 56 KBs. Now, this is an internal conference, right? And we will be using some undocumented comments, which I would say undocumented from Microsoft's perspective, but there is some kind of good documentation from other sources, people from the community, and even from like Paul Rundle, people that probably wrote some of those comments. So the first undocumented comment that I want to share about is the DBCC int, which will list all the pages that are allocated to an index. So here we can see that we have 170 records, and the records here have some different page types and what is the pointers from one page to the other, etc. Nowadays, or more recently, we also have a new DMF, a data management function, a dynamic management function that allow us to get some kind of the same results with a little bit more details and descriptions. But still, we can see here our page descriptions. And here we can see that we have 177 records. So this second comment is showing 7 more page or records in this case compared with the DBCC int. So the difference here, just to explain, because depending on what you are doing, you may want to use one or the other, is to share that the DBCC int shows the 170 page, and this means 168 page that are the data that we have. And then we have 2 index pages. So when we see here the 2 index page, one being in this case the EAM page, and the other one is a page belonging to the cluster index. The 7 page that we see being more on the second result set, these ones are belonging to this data page that are not yet allocated, and therefore they still appear here because, or they are allocated, not being used, and therefore we have 7 page times 8 KBs will be the 56 KBs that we saw before on the SP space used. Now, another 2 comments, one maybe more known for more people, which is the trace one. So is the comment that we can use to enable trace flags on SQL Server. This trace flag 3604 will be so we can dump a data page from SQL Server to our message console instead of going to the error log. So we'll need to turn this on, and then we will be using the DBCC page to show for a specific database what is, and picking one page ID, we will then print, and in this case I'm using the option 3, which means that we'll get the page header and then also details per row. So let me pick here one data page, and let's see what we can see here. So this is a data page, and with this option we get a buffer part of it, and then as we saw before, we have a page header, the one that occupies the 96 bytes, and then we have the information per record. So we can see that we have a primary record with a record size of 25 bytes, and then our values are here, okay? So let me pick this, because the past call you said to copy paste this to a new window. And now let's see what happens when we add a new column. And this is a column, job title, varchar 50, and allow nulls. So adding this column is just quick, right? And if we see, the column appears here with the null value. So what happened in the end when we add this new page? So if we pick again the data page, and let's put these side by side, so we can do a comparison on a couple of things. So one of the things that I want to show you is this MLSN value, which tell us what was the last logical sequence number that was written and that changed that page. And as you can see here, even that we had the column, this didn't change, which means that our page was not written. So the SQL Server doesn't have to go to each and every page, change the page to add the column and to add a null value, okay? So this is a proof in the end that this operation is a metadata operation instead of being a writing operation afterwards. So we can also see that if we check one of the records, and here the same, that here we had our 3 columns, and here now we have 4 columns where our job title appears with a null value. And the interesting part here also is that we don't have yet an offset on the page, meaning that we don't have a value. So again, this is some kind of metadata that SQL Server stores and knows where it is. And right now, because we don't have data written there, we have a length of 0, and also the physical length is 0. Now, how do we know, or how the engine knows, after all, that this column exists, and whenever someone does a select, it will need to show some extra columns. So the columns are already there, but for us, if we are seeing the data page, we don't see values there. So how the engine knows that? So enters a couple of system views, also undocument, which are called the system internal partitions and also system internal partitions columns. So I will join both here. We have a lot of data here. And I mean, because we don't have official documentation, we can only infer some of it. And we can see that how many rows were modified. My last column haven't modified yet any records, the data types, the max length, and a bunch of other values. So if we just pick a fewer columns just to make it easier to read, we can see here that for our index ID 1 and our partition 1, we have 4 columns which has these names, and these are the modification count, and we have the information if it is nullable or not, and what is the default value, which is in this case is null. So now let's do an update on our first record of the table, ID number 1, and let's say that the job title, is developer. And if we now pick the page and check again the differences, now this LSN changed. So before, if we pick one of those, it ended in 6841, and now it's already 22. And if we check here our record, we now have a proper or a value for the job title, and we can see that we have an offset, also a length of 9, because we have 9 characters there, and the physical length is also 9. So we saw the MLSN changed, and the actual value is also there. However, someone will say, well, but this was 50,000 records. These are very few number of pages. Doing that change, even more on the system that is not doing anything else, will be quick. Yeah, sure. So let's say that we had 1 million more records to our table. And then we will add again a new column. So right now we have 1,050,000 records. We have much more space being utilized. And if we check here and add another one, is still quick, very quick. So let's move to a second demo, which will be about adding columns that do not allow nulls. So they will have a default value, and we will see the implications of doing that. So the idea of this session is not only going to these internal parts, but also to correlate with real life challenge and scenarios, and give you more information that next time you need to deal with these situations, you can say, oh, wait a second, let's not go that way, let's do the other way, because I saw A, B, C. That can be a problem. So let's drop and create our client table, a table with 3 columns. Let's insert 50,000 records, and let's add the job title with not null, and adding a constraint to say that we will have a default value of not defined. So do you think this will be fast, slow? It's fast, okay? And if we pick again on our list of columns, we see that we have the 4 of them, is not changed. And what we can see on our shorter version, now we can see that we have our job title that shows that we have this column has a default, and that default is not defined. This is on the metadata on these system views. So does that mean it is inside of our data page already or not? Let's have a look. So if I dump one page, I can check here that my column seems to have a value of ND, but take a look, doesn't have any offset. So this actually says that it's not written in the data page yet. Also, it knows that he has a length of 3, the 3 characters that we have here, but again, the length, the physical length has 0. So this, what it says is that the metadata is being used to populate and to give you the outcome whenever you just add a column and you said it's not null and have a default value. But I'm running here a developer edition, which is the same behavior as an enterprise edition. What can be the difference if we are on the standard edition? So do you think it will be the same? Let's see. So here I'm running another container with standard edition, okay? And I will create the same table with the same records and add also the job title column with the same definition, with the same constraint, with the same default value. And this is fast. because no one is using, the table has a few data. But what are the difference on our metadata side? So here, we don't have information about having a default, neither which default value would be. So is this a bug? What is the problem here? Let's take a look inside of one of the pages to check what we can see there for this new column that we just had. So here, we can see that we have the column number 4, which currently has an offset, which has 3 bytes, it's here, and actually has also 3 physical bytes, meaning that our record was written on the page. So let's insert a little bit more records, another 5 million. So the main question here, or the main thing to retain, is that the main difference between the enterprise or a standard or lower version is that adding a not null column since 2012, SQL Server 2012, is again an online operation for the enterprise edition, meaning that only this metadata will be stored, and this can be a kind of instantaneous addition or an instantaneous run that will make possible to have the table functional and not like blocked because we need to write everything in every data page. So now with this, we have 5,050,000 records, around 150 megabytes. And let me drop the constraint, drop the column, and I will add it again. And I will run here the SPU is active to check with the get transaction info. So to check that when we do this addition, we will take some time to run. So we go with 6 seconds, and we can see that our transaction log is being written because our pages are being updated to be able to add this column, okay? So it finished for 5 million records. It took 10 seconds to update these 5 million records in order to add the job title column with the default not null. So be sure that you know this, because this will make as being an offline operation, meaning that your table will be locked and cannot be utilized by other sessions. And a different way of doing it, and also the way that we will do it in 2012, or even before 2012, and before, or not having enterprise or with enterprise too, would be to add a column that allow nulls. You will need to do a bunch of controlled updates to update every row to your default value. And afterwards, you will be able to add a constraint. But at that point, because the data is already there, it will be a little bit more quicker than read and write every single page there. All right, so let's come back to our enterprise. And let's do the same test here about the 5 million records. So we saw it took 10 seconds to run on our standard edition. Let's go and add here our 5 million records for the enterprise edition. Let's see that we can see that exact data. And then we will drop and add again our column. So we have here our 5,050,000 records. Let's drop the constraint to drop the column. And now let's add our not null with the constraints and the default value of ND, and boom, it's done. So it took less than 1 second. Okay, so this shows this is a kind of instantaneous, and this is the metadata operation. However, this doesn't work with all the defaults, okay? And this is on the documentation. The documentation is pretty good in these points. So what it says is that it will only work for a runtime constant, which is an expression that produces the same value at runtime for each row, even if it's not deterministic. So I mean, whenever we think about being deterministic, is something that we, for the same input, we get the same outputs. So just by that, I would not expect that a get UTC date would work, because if I run with a different input or input different moments, it will receive two different outputs. However, it says that is a runtime constant. So let's see an example. If I add the update on a datetime 2 with precision of 3, and with the get update, the get UTC date, this will be instantaneous. If I do some default string like we did with the not defined, also instantaneous. And if we check one of our page, what we see is that we have our job title, which is still without an offset and without a physical length. Now we have also the update on and the update by. All of them were added through the metadata and not by writing every single page. So what happens if we try to add a unique identifier with the default of the new ID? So if we run this, now I can come back here, try to be quick enough to change to this one and still get the session running for 12 seconds because it's still writing data on our transaction log to register all the changes that is being done on every page of the table. And now it's done, and it took 24 seconds for this table. So if we check again here, what happened? So to add our unique identifier column, it actually had to write the value on the page with 16 bytes. And again, that proves that for these specific defaults, it's a no-go being online. So don't go and rush like, oh, I can add whatever I want as a default because it won't write in my tables. So any questions so far, Jess?
Yes, we got a perfect question for this spot. And that is, are you aware of some comprehensive sources of information for what DDL operations are offline or online and under which conditions, editions, etc.?
Excellent question. I don't think I ever saw like a short list or a summary of those. So if you compare like the features between standard enterprise, you will see some stuff like some stars to say, well, in this case, this is an online operation, or in this case, you can use not one single core, but multiple cores and stuff like that. I don't remember to see any specific summary table with the operations that are allowed to do and the difference between standard enterprise. And then we are using just our regular tables, disk-based tables, I don't know, about in-memory tables and other stuff. But if anyone ever seen that before, I would love to get that and to have that short summary too, because more often than I would like, I find myself doing a small demo just to double check something before going and run somewhere else because I don't know exactly the implications of it.
Yeah, totally. Cool. One more question for you. The metadata only operation with the not null column with the default value, is that just available with 2022?
No. Since 2012, an enterprise edition, this exists.
Perfect.
Okay.
Thank you.
So that is the one. No problem. Thank you. All right, let's move on. And we have seen how to add columns allowing nulls, and that is like online and not a writing operation for every page. We have seen how we can use Enterprise Edition to do that for since 2012 as being a metadata operation, and therefore with some caveats like which defaults we use can be an online operation. But what if I tell you that adding a null or not null column can update an entire table? Forget about what you just heard before, but this can happen in a very specific situation. But I think it's cool to be aware of it. So let's see. let's create our table again. This one will have here a new column, which is the bio, and on purpose we'll have 7,992 characters, and it will be a char, meaning that even if I don't write anything, this will occupy 7,992 characters. And that is important for the point that I want to show. Now let's add here half a dozen of records, and let's see one page here. And what we can see here is that we have our record size is 8,042 bytes. We can see a bunch of data here for the char column. And on the bottom, we can see that we have our ID, our first name, our date of birth, job title, and our bio, which has this bunch of empty space. So now let's add another int. So an int column with a not null, default 0, and we are on the Enterprise Edition, okay? So if I add this, I have trouble. So it first says that the table client has been created, was created already, but still, and it exceeds the maximum size of the 8060 bytes that it can be. And then it says, be aware that insert of updates that will result in more than these lengths may fail. And we can see that it says cannot create a row with the size 8064, which is greater than the allowed maximum row size 860. So I warned about the 860 on the slide on the PowerPoint, but here it's saying that it cannot do these 4 extra bytes, which is the size of an int, right? It's 4 bytes. So let's take a look on one of the pages. So each record in this case is occupying is belonging to one page and just one page. So let's pick one of the bottom 3 pages and see what we have here. So before, on the other record, which was the first record and the first page of the table, it said that our record size was 8042, but here is 8060, which means is already the maximum value that you can have on a single record in one page. And this is for the hello, I'm Irene. And if I go to the bottom, what we can see here is that we have something new and some stuff. So we have an ID, and then we no longer have all the letters being repeated in the record, and now we have a different thing. We'll come back in a second. We have our date of birth, and also our job title is also different from as it was before. So let's say that I will delete the records with IDs 4, 5, and 6. And just to show the difference here is that the records that were inserted, these bottom 3, they insert 30 characters each, and the ones before just inserted 15, okay? So what happens if I delete these records that occupy 8060 bytes? The delete succeeds. And now what happens if I try to add the column again? It worked. I no longer have the red message. I still have the warning message saying to me, hey, be careful, because if you go crazy, you can surpass the 8060 characters, or bytes in this case, but no longer fail. So the column was added. And to prove that, let's see, I need to pick again one of the initial page. And this is hello, I'm Alex, meaning it's one of these first records. And if I scroll down to my data here, I can see that after my bio column, now I have another int. But we are on Enterprise Edition, and we are adding a constant value as a default of this column. And what can we see here is that we have an offset and we have a physical length, meaning that this had to be written on the page. So what happens here in the case? If the engine detects whenever you are adding a new column, that you can surpass the value of the 8060, to be sure that that doesn't happen, it needs to go and update every single record on your table. If any of these records, by doing these updates, will fail because it surpassed the 80,060 bytes, then it fails as it failed before. So if it happens, abort, roll back. So if I try now to insert a record that exceeds the 80,060, I get an error saying again, cannot create a row with the size of 8064 because the maximal out size is 8060. Now, the question is, this can take some time to fail. And why? Imagine that I have 500,000 records. So I'm dropping and recreating or creating a table called fail slow. And I will show you that it can take some time to give the error saying that could not update. And while that is happening, because we are writing operations, the table will be locked. So no longer the metadata only operation. And therefore, this can create impact on your systems because they are running and someone else may need to access this table, and that will be locked. So with 500,000 records, we will see a new comment, dbcc show config. So this is documented, and this shows the fragmentation that an index of the data on the index or a specific table or view. If my inserts finish in the meantime, okay. It's taking longer than I was expecting.
I've got a question you can answer while that runs if you want. So
It's,
back to the metadata, where is that stored as far as the defaults? We have a comment about adding a column with a default and then dropping the default, but the value stays on each record. So where is the metadata stored?
it's stored on that system. Let me pick it here. On this system internal partitions columns, that is the one that has the default value column. So cool. That is where the things are saved for the enterprise edition, because on the standard edition, as long as so for each version, even standard or enterprise, as long as you write on that table the value, so you persist that value on the data page, it will disappear from here from the metadata. If you just add the column like I did here and you check the metadata, it will appear saying you have this column with this default, which has a default, and the default is this value. Whenever it is a standard, this metadata will be always saying, yes, I have a default, but the default will be null because it's already persisted on the data page.
Perfect, cool. And kind of a related question to that is regarding availability group replication. If the changes are updating only metadata and not right into the transaction log, are they also being replicated to a secondary replica of the AG?
Yes, they will. So any operations and so whenever you create a table, whenever you change a table, those DDL operations are being replicated also for the secondary.
Perfect, thanks.
Thank you. So now it finished. It took a little bit longer than I was expecting. So let's see what this show config command showed to us. So it showed to us that we have this index, which is index ID 1, how many page I have, and in this case, how many rows. And as I said, on purpose, I'm putting a maximum of 1 row per page. And the important part here for now will be this data here. So the minimum record size, the maximum record size, and the average record size give us an idea that well, to the 8060, I still have 18 bytes that I can use, right? So now I will insert a record, another one. So I insert 500,000 with the replicate C and F 15 times, and now will be the I 30 times. This just runs okay. Let's check again our show config. So what changed here? And what changed here was our maximum record size. So by adding this new record, and instead of having the 15 linked on these characters, I had 60 because I knew and I did the math, will give us the maximum record size that we can have. So what happens if I try to add another int to this table? Oh, it's running, cool. Oh, I will pick a coffee while this is running because it will take, oh, wait, it's taking some time. And it's writing on my transaction log. Oh, but yeah, okay, I have on my maintenance window, no problem. So this will finish soon and I will be okay. Oh, already finished. Oops, it finished with an error. And it took 17 seconds in the end to be able to give an error. Why? Because that was the time it took to write all the previous 500,000 records, and then it reached the one that could not get these extra 4 bytes, and then it fails, roll back everything, and our table don't have our new column because of this. So how to solve things like this? Well, the first one will be not letting the user write an essay or like a big history about the bio. And of course, instead of having a char, you can have a variable length column. But of course, just to show here, if I create this table with 4 less bytes here, and I insert 50,000 records, so this will be a little bit quicker than the 500 before, then I can see the show config here, and I have 8,056 as a maximum one, meaning that now if I try to add my integer column, it will succeed. And if I check the records, and now here, a new thing to take into consideration, because it didn't surpass the value of the 8060 or could not surpass, it didn't write on every single page, meaning that the current page actually just have 8,056 bytes. So be careful on relying on these outputs to say by default, I have enough space to add another X bytes, okay? So if we check our table and dump one of the page, so what we'll be able to see here is that our column was added, I have the default value, and again, no offset, no physical length, meaning in this case that was just the metadata operation and not a writing operation. And again, to show and probably to give some clarity to that last question, here you can see that we have another int, and it has 4 bytes. It has a default, and the default is 0. If we were on the standard edition, these here will be null because it was already written on the data page. But now, just to make the things a little bit more interesting, you may be confused about this. So if we sum the value of our max length, it will give us 8,059 bytes. So not 8,062, not 8,054 or 56 that we saw before. So what's happening? So what's happening is that the way that the size of one record is calculated, it isn't just the data types of the columns. There is a couple of extra parcels that you need to use and to make it as an addition. So there is also documentation about that, how to estimate the size of a cluster index, of a non-cluster index, and even from a heap. And just doing here a quick math to help, we have a cluster index which is unique. In case it was non-unique, we need to add an extra byte in 2 of our variables for our calculation. Then we have a null bitmap. So null bitmap, this is again per record, meaning that depending on the number of columns that we have a null bitmap which will control the nullability of the columns in portions of 8 columns each. In this case, I have 5. 5 plus 7 will be 12. 12 divided by 8 will give 1 point something. 2 plus 1 point something will be 3, and the documentation says to discard the remainder, meaning that we have 3. So 3 bytes other than the size of all the columns. But then we have also the variable data size. So the columns that have variable length, and how this is calculated is 2 bytes plus the number of columns times 2 plus the max variable size. So I had 2 columns with the varchar 30, meaning that I have 60. Doing this math, I have 66 bytes extra. And actually, there is an extra 4 bytes, which are a row header overhead that is present on every row. Meaning that other than the size that we have, the fixed and the variable, in this case, for this amount of columns, we have an extra 7 bytes of overhead. But if we sum all of these, our int plus our date plus our char and another int, plus our variable length, so this is 7,999, plus our 66 from the variable length, plus 3 plus 4, after all, I have 8072. So again, what's happening here? This is much more than 860, but it's working. So the thing is, when we have variable length columns, whenever that exceeds the 8060 bytes for the records, what the engine does is that it creates a 24-byte entry on the page and creates a pointer for a row overflow allocation. And on that allocation is where we will get our record, our variable length. So what happens in that case is that instead of having 66, we will have, instead of having 60 bytes, we'll have 24 times 2, which is 48, which plus the same 6 that we had here, it will give us 54. And now, if we replace the 66 by 54, we have the 8060 bytes here. And then if you want to know how much data, how many records can fit in one page, you can do also this calculation. So there is a value of 2, which is the entry for the slot array to say where the record is on the page. And in this case, for us, will be 1.004, so 1 record per page. Things important to take into consideration on these kind of calculations. It doesn't work that way with partitioning, with about the location page, the lob data, compression, and so on. So this is, let's say, the first simple example that I can give to show how the calculation is done. If any of these other things is involved, most probably you'll get to different values and values that does not match exactly what you would expect. So I mentioned row overflow data allocation, right? So if I go here and I pick one page, or I check what I have here, and I have here some page allocated. If I dump my page, now I will see again that I have these 2 pointers. So this is the first name is a column that has a length of 24 bytes. Why? Because he tracks whatever is inside by pointing this information or getting this information and pointing to a different page, okay, on the system. And here it just knows that it has 30 characters in this case, okay? So in this case, if I pick the one of the pages that are where it is, that are the page that are here, but from the, I need to go to the final ones. Sorry, here, yeah. You see that I have a row overflow data instead of having an in-row data. In-row data is the default, is when a record fits inside of the page. When we have these pointers that need to point to something else, in the end, what happens is that the engine creates a new page, which is of the type row overflow data, and inside is where we get that information. So if I pick one of these, just to show that inside, this page is a little bit different from the others, but here we can see that we have a record. This is the blob ID of the record, and this is the page, the in-row data page where the things are. So it will show, based on that, the pointer and show where it is. And then I know that I have 30 eyes in this case, and for another record, I have a different ones, and so on and so on. So this blob ID is the one that points to the allocation ID on the other page. Cool. Any question?
Not at the moment.
Oh, thanks. So then let's move forward to dropping columns and what that can show us. So what happens when we drop a column? What happens to the space that that column was occupying? It was occupying, is still occupying. Let's see. Let's create this table again, 3 columns. Let's insert here 50,000 records. Let's see that we have 1,440 KBs for the data, 1 index page and 4 page for the unused space. And here we have our page, and so far so good. What we'll see here is that we have our 3 columns with our values, everything is there. Cool. So there is, since 2019, a new DMV, or DMF in this case, is a function called the DMDB page info, which can show us the header of a page. So the same thing that we are seeing on the dump of the page on the header, here it also shows. In this case, in this kind of in grid format, and we can get the same kind of data that we were seeing on the other one. As an example, we have 279 records there, and we can also see that our last LSN was this one, like we saw before. So now let's see what happened when we drop a column. I've dropped a column, and I had 1,440 bytes, and I still have it. Everything is still the same. So what happened? What happened? Like, it's still the same as before. So let's pick and check what we can see inside of our page. So doing the dump of the page, what we can see here is that our 3rd column, that was our date time, and in this case, we knew that was a date time, and we knew that it occupies 8 bytes, is still occupying physically the 8 bytes. But our column no longer has the column number 3. Now it has like this dummy ID, and it says dropped equal null. But our length, our record length, is still the 27 bytes as before. So what it shows is that dropping a column is not a writing operation per se, but rather a kind of metadata that says this column no longer exists on this table. So whenever you go and want to run again, because that column does not exist, it just shows the data that is inside of each page for the columns that actually exists. So as a curiosity, if this was related with deleting a record and not dropping a column, what happens is that you will see a ghost record on that page, and then the inserters that will, so when someone inserts data again, that will be overwritten and use that space. So those are the ones that will pay the bill in the end of the deletion operation. So this means to reclaim the space, I will need to rebuild my table. And then if I rebuild my table and I check the space, now I have only 1,040 instead of 1,400 bytes, okay? So seems easy. It's just to know that this is what happens, so metadata operation. However, be aware, because if you are expecting dropping a column, get space back, and if you, for that, you need to rebuild your table, be aware of, if you are on an enterprise or standard edition, rebuilding tables or indexes in this case, in enterprise edition can be online but on standard edition won't be online. So it's an offline operation. So make sure that you take the right decision when you want to do these rebuilds, when you want to be able to actually recover and get back that space. So this is with the rebuild. However, I have here another example about the DBCC clean table. So can the DBCC clean table help us with this instead of the need of doing the rebuild of the entire table? Let's have a look here. So our table with 5 million records, and let's see how much space this is occupying. And also, we will see based on the index physical stats, which give information, and we can have see the average page space used. Let's then pick this, put it here, so we can do some comparison. Same thing for these ones, but let's put it here. And now let's drop our column. Let's see the space is occupying, again, still the same, no change at all. And let's see what happened on our index. So our in-row data is still the same. Page count still the same. Page use is still the same. Number of records still the same. And the space used is also exactly the same. And now, what about the DBCC clean table? So these are different comments which allow us to run, we can have a batch size, the default is 1000. And what it does in the end, it will be doing a cleanup, but only for the variable linked columns. Meaning that whenever I run this, and if I check what's running, this is a writing operation. So I'm blocking the table and I'm doing something. Meaning that you need to be careful to do not do a bigger size or too big size that will make your table offline and not accessible by the time. However, when we run this, we now can see a couple of different things here. So we don't see anything about the size of the table, so it's still the same. However, here, because we cleaned up that space, the average space on in percentage for each page just lower down 30% or 33%. Okay, so it helped to clean up something, but didn't recover like the page and do not compact the page and so on. So yes, you can get some free space, but not the space that you are expecting that you have with the rebuild of a table. And if we check inside one of the pages, we will see. So it's not, after all, this is not the same as rebuilding the table. It's not recommended to do this in a kind of maintenance operations and running over and over. But yeah, here in the end, after we dropped all the column, is still here, marked as dropped, but we just cleared the space because it was a var, so a variable linked data type. Moving forward. So now that we know that whenever we drop a column, the space is not freed up right away, maybe it's interesting to find if we have more tables that are in that situation. So they have dropped columns, and we want to know which ones they can be. So let's create a table. Let's create 3 records. Let's drop our date of birth column. And if we check our data pages, just to pick, we just have one in this case. I will pick this one. And here I'm using the dump of the page, but with table results, because I want to show you that we can see here on the records that we have dropped and the null value whenever our column was dropped. So we had the ID, the first name, and here was our date of birth, but now it's dropped and we can see it here. So we could reinvent the wheel, or doing as it could be done in the past, And imagine that you create some temp table, you execute your DVCC page, you put it inside, and if you filter by the drop, you see that for one page on one table, there are 3 records, or for these, which means that there are a dropped column. However, there is a better way to do it, and again, is about using our metadata. So let's insert again the data, and let's see what we have here. So with fewer columns, we can see that we have 3 columns, and we have on our metadata system view, we have a is dropped column, which seems to be what can tell us that we have a dropped column. So I have dropped my column, I did a filter for is dropped, and now I can see that my client table now had a column that was dropped. At this point, if I don't know which column was there before, I no longer know, but is dropped, and that means that some space can be probably reclaimed. So if you want to check 2 more, and to check 2 more than one table, let me create here a second table with a dropped column, and here we can see more dropped columns from different tables. So this is the way that you can run. The note here is that if you are running this on a partition table, it will appear 1 row per partition of that table, okay? Just the way it is. You can, of course, change the query to make it for your needs.
Question for you on that one.
Yeah.
Would rebuilding the clustered index also perform the clear of the dropped column as the rebuilt table?
Yes, because in this case, the rebuild table was, if I'm not wrong, because I had a heap, not a cluster index. If I had the cluster index, I would need to do the rebuild of the cluster index, or with the same syntax, but in the end, he's doing the same thing.
Perfect. And you're at like 15 minutes left.
Okay. So now that we know how to identify, we know what happens when we drop a column, how to identify them, it would be cool if we could estimate, have an idea on how much space we could get back if I need to rebuild that table. Because maybe that will tell me or answer the question, I'm in a rush to do that because I will recover 100 gigabytes, or I don't care because it's just 400 KBs or whatever. So to do that, we need to pick from the previous examples, the code that we had before. We have here our space use as we saw before with the 1440 KBs of data. And even that we don't have, again, some documentation for these systems views, we can infer some stuff. And here we can see that we have 28 columns on the 2022 version. And we have information like the max in row length or the max length that we have for a column. So what I did in this case is start doing some math. So I pick some data and I said, well, this is my table. Each one of these columns exists for this amount of rows. They occupy this total number of bytes because it's the max length times the number of rows. And in KBs is this, the number of total page that this size can be translated is 25. Meaning that then I can, when I drop a column, I can see my dropped column here, and I can see that my dropped column has 8 bytes, okay? And in this case, we knew that it was a date time. So with that in mind, we can calculate what is our current page count, or we can not calculate, but get our current page count, and that can be something that you can get from your index physical stats, even with the limited definition, because it can be detailed and it will take longer to get more information. And the final math here will be picking that information and say that, okay, we have this column that is dropped, and it has 8 bytes max length. That means 400 KBs, which means 50 page. If the current page count is 180, if we subtract the 50, we'll have 130, which means that if I rebuild my table, I may expect to have something around 1040 instead of 1440, okay? Let's see if this king works in this case. It rebuilds, let's check, and our table now has 130, so the 50 page less compared with the before one. And again, caveats on these calculations, compression and stuff, because that will be harder to calculate these values. We have two more demos. One, the question is, do you really want to rebuild your table, yes or no? Why bothering doing so? What happens so if you take 1 month to rebuild your table because you have that maintenance window, is this bringing any problem? Let's have a look here. Our table, 50,000 records. We have an average of 27 bytes per record here. We will drop the column and check again our average size, and still 27. We have seen this before, so no writing operation. Our records still take 27 bytes. So what happens if I had another 50,000 records? What will be my thing is still 27. But I had 50,000 records with 27 bytes, and now I had 50,000 records with 19 bytes, because it's the 19 plus 8 of the dropped column. Well, it seems that is not what happened. And to show that, let's pick here a page. Let's dump our page. And let's see here, this is one of the beginning records. So ID number 1, it says that I have a dropped column. We already knew that. But if I pick the latest column or the latest page that is a data page here, to grab one of the other IDs. So here, I'm now working with the ID 99883, but look, our reference to our dropped column is still here. So every new page that was added to insert more data on the table need to bring these overheads and to still write and say, well, it's still 8 bytes here because no one rebuilt the table. But if I pick and do an update on one of the columns here, if I go here, it's still there. So what this proves, either insert or update records won't write and remove the waste of space that you have inside of your data page. So you actually need to do the rebuild of your table to reclaim this space. Final one, adding and removing columns without rebuilding in the middle. So at some point it will fail. Why? Let's have a look. I have a table with a much better bio size, or not, 7,000 bytes still to write an essay inside. I will insert one record, and I will drop my bio column, which has the 3,500 nchar, meaning 7,000 bytes. And I will add a new one with 300. It worked. Cool. Now let's see what is my show config here. I have a maximum record of 7080. Okay. So that means that if I add another 700 bytes, it should work. But no, it doesn't. And why? Because adding this column will change the max size of a record for 8214, including the 7 bytes that we have calculated before, with the 4 bytes for the row overhead and the 3 bytes for the null bitmap. And it says, well, no, we cannot, because you cannot have records more than 8060. So if we pick our page, and here, as you can see, we are working just with one data page. What happens here is that we have still our bio column here. And if we go here to the bottom, you can see that our bio column was dropped, 7,000 bytes. our car column was added without a problem, but because we still have this one, right, adding a second column with another 600 bytes will result in the oversize of the record, meaning that no, we cannot do it. So, and you can see here that in your metadata, your column is still here being dropped. And we were able to add another one that has 600 bytes. But sure, if I try to another one, 7,000 plus 1,200 will be 8,200, meaning that it will surpass the values. So if I rebuild my table, I can now see that my dropped column just went away. And adding the second column with the uncard 300 won't fail anymore because now I have space for it. There is a but, and this one is about, here we have like the same table or almost exactly the same table, but our variable length column is the end of the table, not before the date as it was on the previous one. And in this case, it seems that SQL Server can rely on the amount of data that was there to overwrite somehow and put it there. So here we see that I have dropped the column. I will have my 300, the first column, it succeeds. And this one that failed before, because I haven't rebuilt my table, if I now add it, it still succeeds. And if we see here, the other one just disappeared, and in this case, without the rebuild. So if we check inside of our page, we will see that there is here some data on our, but also here the new one inserted. So the column is still marked as being dropped, okay? The other two are news and they are without physical size because they were added as a metadata. But this one disappeared from the metadata, and this one I don't know like what the engine is doing in the end. My assumption is that he's picking on these two, and because we dropped that and the data type is the same, he can overwrite already because he's on the end of the page, let's say. So if I insert a new record here where I have my new column and new column 2, and I check my page again, just to show that we have here the initial data, and somewhere here we now have our, sorry, I need to pick the second page, not the first one, to show that in this case, you can see here the hello, I'm Alex, and then in the middle, you see hello, I'm Alex 2, which is based on the new column, and at some point we see garbage. So these are like used to be overwrite in the end. And if you go down here, we can see that we have our value with the 600 length and our other value with 600 length. And that's it. Hope that you enjoyed. I know, Jess, if we still have time for questions or not, then I can take it offline.
I was going to say, yeah, we've got about 5 more minutes for questions, but I think everyone's mind is melted. We've got no questions on the last couple. Just a lot of people in awe at your presentation style and the stuff you've shared. We've been loving it.
Oh, so hope that we all learned something. I learned a lot during this session. A lot.
So that's my
When
question.
I asked you earlier, did you have any demos for your session? You said a couple. That was fantastic.
Let me say this way. If I had enough time, or more time, I had enough. I had more demos to do. I have another 3 demos that people can do as homework to double check something, right? That is my problem with doing sessions, is that I like to share a lot of demos and I have a hard time to select which one should I show.
Yeah, I think when we first talked about what you were going to show, I was like, Claudio, this is way too much. But yeah, there's so many good demos. And like you said, the homework ones are just as good. So we've got one question from Jeff about compression. You mentioned that compression changes some things. Can you highlight any of the major gotchas for how that affects some of the stuff we saw today?
Yeah, so the compression. So the data that is saved on the data page will be already compressed whenever you say that you want to have either row or page compression. What I can show, you see, Andrew, this is useful. About the compression is that we have, so the question would be, we will have the 8060 bytes before or after the compression. So the easy answer is your record uncompressed needs to be no longer than 8060. Then the compression will be applied. Okay, so that is the one. So doing the calculation with compression is difficult because depending on the data that you have inside, the data types that you have, how repeatable the things are, applying the compression algorithm can give you different results, right? Different values. I did the test of getting how much space I expect to get back from a dropped column on a compressed table. And at some point I had, well, you will get minus something because that calculation was not working as not as it should, but you cannot rely on the max size of that column whenever the compression is applied, because most probably it can be less than that. So I would say you can jump here to the data compression information and get some and run on your pace this demo to show that you can only have 8060 bytes of uncompressed data and the compression only be applied afterwards. So if you want to go back from data compression to none to known compression, the record needs to fit inside of one page.
Nice. One other question we had was whether these demos are available for download from anywhere.
Yeah, I will share on the Slack channel my GitHub, but I think later 8KB should also update to the central 8KB GitHub. Is that correct? Nice.
Yes.
Perfect.
So thank you.
Yep.
Yeah, I would just
Thanks, Claudio.
Thank you. Thank you, Jess, for moderating, and let's see more content.
Are we getting more questions?
We do have a couple more questions.
We've got some time, so.
All right, Claudio, here's one more for you at least. Would a reorg work in order to reclaim the space, or do you need to do a rebuild on the table?
Sorry, can you repeat the first part?
Yeah, would a reorg work in order to reclaim the space, or do you need to rebuild on the table? I presume this is for the dropped column stuff.
I didn't test that, but it's need a rebuild because a reorg will just move records inside of the same page, meaning that the space that is there will be moved along still. So the most close to that will be the DBCC clean page the clean table that we saw, but with the big gotcha that is just for variable length data types. So yeah, won't do that.
Perfect. And then are there any caveats with data encryption? Not exactly sure the context of that one, but
I'm not sure. So data encryption. I'm not sure. I haven't tested that on with data encryption. I don't know if data encryption will enforce a writing operation on these situations. Something to be tested. I don't know the answer to that.
Yep, no problem.
Also here you can get a bunch of other resources that I found along the way, and some blog posts I wrote about, especially from the drop part of it. And I had here some kind of helpers from Paul Randall, which show us about the DBCC page, and also this is a big one. I like this post about the anatomy of the page, which shows for the header what each one of these things means, And with that, you can have a little bit more information about it. So this is just a copy from the blog post from this source, but can be useful.
This might be one of the most well-prepared sessions I've ever seen, Claudio. Nice work, sir.
Thank you. Thank you. Yeah.
How's everybody's heads doing?
Not good.
All right.
Melted. Yeah, that was really cool.
Oh, fantastic. Thank you so much. Oh, my turn to share my screen, I guess.
Thank you.
Oh, who's joined you, Rob? Do we have another moderator there?
Yeah. The lovely Tracy wanted to see how Claudio did, because we do have a complaint, Claudio. Like, so the complaint is it's your second language. Your brain works so fast. You speak so fast. You know so much. You're smart. You're good looking.
You're funny.
You're funny.
You deliver beautifully.
You give great hugs. I mean, come on.
I try my best, is what I can say. But thank you.
That was amazing.
So yes, absolutely fantastic session. Thank you so much, Claudio. And what a session to kick off EightKB 2024 as well, diving straight into the demos, melting everyone's heads. And we're going to keep it up. We have posted up the links to here, the online resources. So GitHub, YouTube, web, Twitter, email, all that good jazz. What I do want to point out is please do leave feedback. If you take the QR code there or the link there, it'll take you to our website that'll have all the session links to leave feedback for each one of the sessions. As I said right at the start, please leave it constructive, something for the sequel to build on. And of course, there's a link there for the overall event. Tell us what you liked, what you didn't like, because we always want to keep improving and making this event as good as it possibly can be. But I'll leave that up for a few minutes now, but we'll be moving on to our next session in around 12 minutes. So how are we doing, everyone? We all good?
Yeah.
My brain hurts. I didn't know I had to do maths.
I had my fingers out, ran out.
Let's see if we've gone.
And I guess in this call, it probably is maths, isn't it? There's only two people who would be math. Oh no, only one math.
I'm really confused about whether I want a math or maths now, because I can't remember which one's which.
What Rob's not telling you was that he was also having to answer his wife's stupid questions in the middle of that with, why is it 80-40? Who decided these things? Which probably wasn't helpful.
It was all perfectly explained.
I'm just pleased that Trace was on in it. That pleases me.
Oh dear.
I need a cup of tea.
So Claudio, was that did this all come about because of something that you just imagined when you were sleeping, or was it a client-based problem?
Yes, I think was a client. Actually, that asked something to Alexander Arvidsson, and he came back like, "Oh, the client just did this action, and he cannot see the space being reclaimed." So after dropping a column, and yes, so internally we have like a show and tell thing, and I did a fast-paced, quick session about why that happened, because I dumped the page and I show here that things will not be written and so on. And then people say, well, why you don't submit that to 8KB? And I say, well, because then I need to do also for like adding columns or something like that. And so I have a little bit more content, but yeah, sure, let's do it. And then I was digging on the add columns and reminder about the max record size and all that stuff, and try to break things in the end. So to come up with these details about enterprise or not enterprise, and when the things can go wrong. And why, right? So we can take more informed decisions when doing some actions.
I really liked the comparison between enterprise and standard, because I always think of that difference of like big features that are missing or big things that are not there, rather than like there are differences for internal stuff too, right, between the versions that I just forget to think about even. So that was super cool.
I mean, I don't know if you ever seen any system where you will be adding a column and giving this error, but for sure you have seen systems with 200 columns or something like that on one table.
I can't possibly comment.
Yeah, so so the odds to get this problem are real in the end. So it's not that far from reality.
The other thing people were really impressed with was your comment at the top of your scripts at each page. The throw, hey, don't just run everything.
So I had to decide for an error number, right, to do that. And I don't know if you saw that the error number, because it could not be less than 50,000 or something, I had to do the 8KB times 10 just to be something. So I found appropriate for this example will be just 81,920.
I noticed. It was something that I learned to do in PowerShell from a PowerShell person, and I just wondered if you'd got it from PowerShell, or was it something you got from a SQL? The idea of putting it at the top of the script.
He might have some PowerShell experience, just saying.
just a tiny bit. First community person to add a command to the DBA tools.
Okay, we have feedback coming in, and unsurprisingly, Claudio, it's all incredibly positive. So we'll leave those open for a day or so, and then we'll get those feedback forms out to all the speakers. Up next, we have Jess Chapman talking about Azure SQL Database Business Continuity. She's fashionably late, which isn't doing anything for my blood pressure. But yes, everyone, we have 6 minutes. So please go get a drink, get a cup of tea, coffee, whatever your tip of choice, and we will be back in a minute. We're going to hang out here just chatting. Please continue. I had to jump in then, but yes, keep going. I'm going to see if I can ping.
We'll carry on, dancing and singing and telling jokes whilst you panic and get in touch with Jess.
Absolutely. Thank you very much.
You're welcome.
I keep getting nervous every time that you say on the schedule that Jess is up next, and I'm like, "Whoa, no!" It's just Jess with one S.
Can you not hear the difference?
No, every time I'm like, "Oh."
Jess and Jess. I mean,
yeah. I heard it that time.
Good. That's all right. That's good.
Here you go, Andrew.
And there we go.
I was going to say the doorbell has rung.
The doorbell is rung. And don't forget, folks, if you have questions, we have the Q&A in Zoom, and we also have the Slack. If you are on the YouTubes, then please ask the questions in the Slack. There's a lot of fun and games and chat going on there, except when Claudio is melting everybody's brains. Then the chat went a bit quiet. But
and by the way, that was supposed to be a 400 level session. So if anybody disagrees with that, let us know in Slack.
Right. Definitely need to upgrade that one.
Numbering things is art, like naming things is art. So
it's true.
Now, we typically find that all speakers coming here always underestimate the level of their session. I'd agree. That was not a 400 level session.
Someone in the Slack said PhD level. I would agree.
Hello.
Yeah, now that.
Hello.
Hello.
I was watching some of the stuff on Twitter, and I was like, well, that's a tough act to follow. So I'm glad it's a completely different topic. It looked great. Like tons of great feedback out there. So awesome way to kick off the day.
Okay.
Yeah, don't worry. We melted our minds, but then we got some coffee and water and stuff. We're ready to go again.
Am
How are you
I
today, Jess?
making-
All good?
I'm great. Am I making last minute changes to my deck based on questions that I got at work this week? Yes. Yes, I am.
Fantastic.
Thank you.
Perfect.
As I said before, I've actually been sitting next to a speaker who, whilst we were driving to the venue, was sitting there actually writing away, making changes to his session and demos. I don't know how people do it. I'd be having kittens at that point.
Oh, me too.
You do regardless. You
Yeah, so why not?
I've seen you before in session.
That's very true. All right, thanks everyone. I'll tell you what, I'll stop sharing. So whenever you're ready, you can grab the screen.
Can we have more warning before you do that? Because suddenly Andrew is like this big.
Oh, right, yeah, sure. Sorry. Hello, people.
That's worse.
Scared.
Okay.
You have a lot of things behind you, Anthony.
You're on mute.
Oh, yeah.
First person to do that today. Yeah.
It wasn't me. Yay.
All right, Jess, if you want to grab the screen, we'll give it 2 minutes, but we'll let everyone come back. But we'll do a quick check, make everything looks okay.
Jess with one S or Jess with two S's?
I said the same thing.
Someone
Yes,
picked
that's
this and it wasn't
Presenting.
us. I'll test. I thought about that. I was like, every time they say Jess, we're both going to go.
Yeah. Well, I was saying before you joined that I was worried earlier on. Andrew was going through the schedule and he was like, oh, Claudia's up with this. And then Jess is doing this. And I was like, what? Oh, no. Nobody panic.
Okay, hold on. I always forget there's an extra click in Zoom, but you can see my slides right now.
Yep. Looks good.
We can,
Looks
yep.
good.
And you can see my portal screen.
And indeed.
Yes.
Okay,
Might want to make the portal screen a little bit bigger.
even bigger. Okay,
Just-
I'll zoom in
just for you.
again. Okay,
Wish.
better.
Yeah, much better.
Okay,
Thank you.
I know. Again, another thing that I had this week was someone saying, can you see my screen? And I'm like, no. Okay, I'll stop sharing for the moment.
I'm going to jump off and head back to Slack. So anybody has any questions, feel free to put them in there or use the Q&A in Zoom and we will make sure that Jess with some number of S's will get them correctly.
So just Jess, read them to Jess.
Yes.
That's how this is
And then
going.
Jess
Okay,
will-
great.
And then Jess will respond.
Perfect.
We've
It's
got
like you were
this.
awesome. What could go wrong here? Have you got coffee
Okay,
ready?
so it's pretty much 22. So Jess, if you want to reshare your screen, sorry. And you can,
Yes.
I'll introduce you and you'll be good to go.
Okay.
Okay, hello everyone, back for the second session of 8KB 2024. We have Jess Chapman with Azure SQL Database Business Continuity. Take it away, Jess.
All right. Thank you. Welcome to those of you joining for your first session of the day. And thank you to those of you that stayed after I heard an amazing brain melting session, saw some amazing feedback there on Twitter and in the Slack community. So thank you. So I'm here to focus specifically on Azure and SQL database and what I think is one of the most important things in your DBA toolkit, which is your business continuity plan. So for those of you that I have not met yet, my name is Jess Chapman. Jess with one S, as my moderator is Jess Pomfret. Jess with two S's, we make a great team. My pronouns are she and her. I'm a cloud solution architect for data and AI at Microsoft, focused primarily on our Azure databases stack, Azure SQL Database, Azure SQL Managed Instance, Postgres Cosmos DB. I live in Louisville, Kentucky, in the United States. When I am not sitting in front of a computer, I am typically outside hiking or trail running or riding my bike and hanging out with my dogs and kitties and my husband. I am on Blue Sky. You can connect with me on LinkedIn, and I have a GitHub repo in which I keep a lot of my slides and demos. This presentation will be provided through 8KB. All of those links will be available there. So what are we here today to talk about? The fact that today, data is the single most important asset for every organization. I put most on the slide, but I'll be honest, it's every organization these days. Data is the current currency of business. If a company loses access to their data, or if they lose the data itself, they're losing business. They're losing money for every minute or hour that they cannot access their databases. So it is very important for every database administrator to have, every developer to have a business continuity plan, to understand all the aspects of it, to be able to understand which parts of it every application and database needs to take advantage of, and to also regularly work through their business continuity plan and make sure that these things that they have set up work correctly. Oh, and I forgot to say one thing. I love questions. So if you have questions, please post them, and I will take questions as they come up. If you try to wait until the end, I will most likely forget what I was rattling on about at that moment an hour ago. So Jess will let me know if there are any questions right as I'm going through this. All right. So what is business continuity? I found this great definition online as a process-driven approach to maintaining operations in the event of an unplanned disruption. There's two things I want to focus on here. First off, process-driven. This isn't just one set of technology. This just isn't having a backup. This is having a well-thought-out plan and having practiced it, having run books, being able to do this on the regular. The other part is an unplanned disruption. And what I want everyone to realize is how big of a scope that really stands for. Unplanned disruptions are terribly out of sync PowerPoint here, but it can be many different things. We may tend to think of a business continuity plan and disaster recovery coming in when things like natural disasters occur. Gosh, I think back to the hurricane that hit New York City maybe about a decade ago, where there was a story about administrators having to carry gas cans up like 19 flights of stairs to keep a generator going to keep their data center going. That was such a rarity, it made the national news. It is the other everyday little things that happen that we need to be prepared for with our databases and our applications. Data entry errors. 90% of the time that when I was a DBA or as a consultant that I had to bring in, that I had to be brought in to fix things, it was this. Someone runs a delete without a where clause. A statement is run against a database in the wrong environment, running something in production instead of development, for example. Raise your hand if you've ever done that. I've done it. Running things against the wrong table. There are so many things that can go wrong. We're all human. But there are also other things that can happen with hardware, right? CPUs can fall apart, memory can be disrupted, networking can go down. I remember when I was a very junior DBA, just learning the ropes. The first business continuity time that I ever had to deal with in failing over to a secondary data center was when a road construction crew outside our building hit a networking cable, like the fiber cable that went into our data center. Nothing we did, not a natural disaster. So these are the things so that's another example of something that you can't necessarily plan for, but will happen. Natural disasters can happen. And then there's also the other big one at the end of the slide here, which is how can we keep databases going when we are implementing things now like CI/CD, continuous software deployments, especially when companies move into a cloud system like Azure, right? They are there because we're not in an environment where we can take a 12-hour outage on our databases one Saturday a month to do all of our app and database upgrades. We're looking for faster, we're looking for more agile. So all of the things that I'm going to talk about here today are going to cover situations that encompass all of these different options. So the fundamentals that I'm going to be digging into today and really talking about how they work in Azure include our backups, restores, our high availability, and our disaster recovery. So backups, to define them simply, they're going to be a transactionally consistent record of your database at a specific point in time. Restoring is taking that backup and recreating the database as of a point in time. And as I'll emphasize again throughout this presentation, a backup is only as good as its ability to be restored. And just because we have moved into the cloud, rather than being on premises, that does not make it any less true. When we're talking about high availability, we used to talk about this kind of being recovery within the same data center when we were on-prem. When we're in the cloud, it really encompasses your main region that your database and probably your apps are deployed to. And we also want to cover disaster recovery, so data across a secondary data center or a secondary region. And when we talk about doing this in the on-prem SQL world, how would we handle this, right? You'd have DBAs that had set up backup jobs, many different ways to do this, maybe SQL Server agent jobs, maybe a third-party tool, probably going to some storage on-prem, hopefully restores being tested regularly, then setting up, failover cluster instances, always on availability groups with synchronous secondaries for high availability, and maybe even depending on the app, depending on its RPO, depending on its RTO, using something like availability groups or log shipping for disaster recovery. And that's a lot of work, especially when a company has hundreds or even thousands of SQL Server instances with 1 to 10s to hundreds of databases on them each. So the promise is that when you move into Azure, right, Azure is going to make it easier. Azure SQL Database does the heavy lifting for the DBA. But in my experience, you still need to know how it works. You still need to understand all of the finer points of where are the backups stored? What could cause them to not be there? How do you plan for that? How do you do your restores? What can you set about high availability? What can you set about disaster recovery? And that is what I'm going to dig into today. But first, I want to take a look at some core Azure architectural concepts. This is a framework that you'll need to understand to make the best decisions about how to deploy your compute and your storage and your business continuity strategy. Let me get my fancy laser pointer out here. So this outer box encompasses all of Azure. And Azure is going to have multiple regions. I'm using a couple of examples here in the US, East US 2, Central US, North Central US. Some of these regions are paired. This means that they have special connectivity between them, certain geographical distances, and there's a lot of benefits to paired regions, like when updates are being done in a region, it will only be done in one of the paired regions at a time so that you aren't going to be affected if there is some sort of availability impacting event. So in this case, East US 2 and Central US, those are paired regions. Now, within most of our Azure regions, we have what are called availability zones. At least 3 of these will exist in a region if it has zones. So what availability zones are a group of data centers that have separate power, separate networking, separate infrastructure, cooling, all of that. So it offers an additional layer of availability even within the region. So for example, here in East US 2, we may have 3 to 5 data centers in availability zone 1, some in zone 2, and some in zone 3. And the paired region also has this. One thing to be aware of is there are a subset of Azure regions that do not have this or do not have it yet. And that just has a group of data centers. So this might be a choice for you as we go through this and you understand how this plays into your business continuity strategy. This is something you seriously want to be looking at when choosing regions for your databases, for your applications. Are there availability zones? Are they going to offer you that additional level of protection? And I will reference this slide a few times throughout this presentation.
Just before you move on from this slide,
yes,
is there a document where we can find which regions are paired together?
Yes, there is. It might actually be in my resources slide at the end of the deck. If it is not, I will add that before we post the slides.
Perfect, thank you.
Yes, you're welcome. And if someone could just take a note, because I will forget that in an hour, that would be great.
I'll do them.
Okay, thank you. All right. So let's dive into our business continuity strategy, starting with the first line of defense for any of our databases, which is backups. So let's start with the fundamentals here for Azure SQL database. Now, there are 3 different service tiers within Azure SQL database: general purpose and business critical, which have one set of architecture, and then the newer cloud native hyperscale tier. So let's focus on general purpose and business critical first. These take the traditional file-based backups that you may be used to on premises, like taking the full backups and differential backups, transaction log backups. So one thing to note here is that all backups taken within Azure SQL database and Azure SQL managed instance as part of the platform as a service offering. These are stored in Microsoft owned and Microsoft managed storage accounts and containers. One of the benefits of having a platform as a service application like SQL database is Microsoft manages that for you. One of the downsides is Microsoft manages it for you and you don't have access to it. So when it comes to bringing data into Azure SQL database, you cannot restore backup files into it because you can't access Microsoft's storage containers. You also don't have the ability to take out the backups, so you would have to use the backpack method to export your full database data. Now we'll get into things like how often these backups are taken, how they can be restored, but a really important point that I want to note is this. If you delete a server, right? So in Azure SQL, you have your logical SQL server, which can have one or more databases attached to it. The database backup container is tied to a logical server. So if a server is deleted, number one, all the databases under it are deleted. And number two, all of the backup containers under it are deleted as well. There's 2 primary things I tell everyone. Number one, use resource locks on your SQL servers. Make sure that that lock is set so those resources cannot be deleted unless that lock is explicitly cleared by an administrator. Another option you have, which we'll talk about again in a couple slides, is using long-term retention. For databases that need it for regulatory or compliance purposes, it's available, but it is also an additional level of protection against that. And we'll find out why when we get to that section. So now to flip over to hyperscale. Hyperscale is this distributed architecture I'll be showing more about that in the high availability section. And again, it was born in the cloud native. So it involves using file snapshots and log backups. And again, these are stored in a Microsoft-owned, Microsoft-managed storage container. Exporting data would again be done through backpacks. You don't have access to the snapshots or those log files. Same thing here. Deleting the server that it is attached to would delete the database and its backups. So again, we use locks to prevent that server resource deletion. And for critical databases in particular, we may want to use long-term retention for our backups. Another thing to note about hyperscale is that at this point in time, we can't modify the backup storage redundancy after creation. We'll talk about backup storage redundancy in a bit. That is something you will have to determine when you create your database, and it is the way it will be for the remainder of that database's life. So how often are your backups taken? This is something that, again, when you're on premises or you're running SQL in a VM in a cloud, you get to choose. But with the platform as a service offering, Microsoft chooses it for you. So general purpose and business critical, they're going to take a full backup every week. You're going to get a differential backup every 12 hours or 24 hours. You can make that choice on your database. And transaction log backups are taken approximately every 10 minutes. So at the longest, they will be every 10 minutes. If your database is heavier transactionally, they will be taken even more frequently. With hyperscale, when the database is created, that first base snapshot is created. Then storage snapshots are taken regularly as needed. They're not like file-based backups where they need to be on a per-minute schedule. Same thing with transaction logs based on the frequency of transactions within the database. Big thing to note here, again, platform as a service, managed offering, beyond maybe picking your differential backups, you're not controlling how often they're taken. What you do get to take care of is your backup retention. So we're going to have two different options, right? Your short-term retention to enable point-in-time restores. This has a minimum of 1 day and a maximum of 35 days with a default of 7 days. That can be changed when the database is created or at any time thereafter. Note, if you say set your database short-term like point-in-time retention backup from 35 days down to 14 days, there is a cleanup process that will remove the backups no longer needed to support that former point-in-time retention. So I have seen some customers do things like create an Azure policy to enforce that all SQL databases must have X number of days of backup retention, because that's a potential data loss scenario there. So always be aware of the ability to reduce your retention days, which could potentially remove backups to support point-in-time retention. And now we come to the long-term backup retention. So this allows you to store a full, and it's full only, there's no point-in-time retention here because of the sheer number of files that would need to be stored, but it does allow you to store the full backup for up to 10 years. So the way that you can set this up is you can say, I want the weekly full backup every week to be stored for 1 year. I want the first full backup that is taken each month to be stored for 6 months or for 24 months or for 10 years. Or you can also choose an annual option where you can say, I want the backup taken on week 1 of the year, or I'm sorry, fiscal week 1 of the year, or week 26 of the year, or every 12 weeks, maybe aligning with a business process, or again, first backup of the year, last backup of the year, and store that for 1 year, 2 years, 3 years. Now, one of the things to note about the long-term retention backup, these are stored in a different Microsoft-owned, Microsoft-managed storage container. Rather than being stored at the database or even resource group level, they are tied to a subscription. So number one, can allow you to recover from a deleted server if that were to happen. And that could be something that happens accidentally. It could be something that happens maliciously. It could even be something that happened on purpose, right? Like this app has been sunsetted, its databases have been sunsetted. But 2 years later, regulatory or compliance audits come into play and you need to pull back that data from a couple of years ago. You can do that with long-term backups because they're at the subscription level. It also does give you that additional layer of protection if somehow the data or the database is compromised. Again, talking about even just the point in time retention days being reduced and how that can change your ability to restore to a specific point in time. Do we have a question?
We do.
Okay.
So regarding RPOs and RTOs, if you cannot directly influence the backup frequency, do you then need to switch to a managed instance or VMs if you need to be able to do that?
So we have, again, published recovery point objectives that are met. So a SQL managed instance is going to have the same options for backups. I think the only thing different is you don't get the option to set the differentials. If you need the absolute control of being able to get more granular, like must have your transaction log backups every 5 minutes without fail, then yes, the only way to influence that is to run SQL in a VM.
Cool. One other question. Is there a way to standardize the backup retention on a subscription level? For example, all SQL databases in a particular subscription or resource group set LTR to 3 months?
There are Azure policies for long-term retention backups. I have not set that up personally, but might be able to be done. If you can scratch a note for that, I'm going to look into it, and we'll probably dig something up on Twitter or LinkedIn afterwards to answer that question, because that's a great question. Again, using Azure policy to enforce these things at a resource group or a subscription level, absolutely vital. Makes things a lot easier, especially, it's not like managing an instance anymore where you can set something like that at an instance level, right? This is per database. So really important. So I'll happily dig up some links on that. All right.
Back to you.
All right. So then the next option is your backup redundancy. I'm going to go through this kind of quickly just because we have a lot of ground to cover and I could spend time talking about all of these, but you have options about how to store your backups within the region, right? So you've got your data center, your availability zone, your region, and even cross region. We offer local redundancy, zone redundancy, geo redundancy, and geo zone redundancy for hyperscale. I can show you all these things on this text on this one slide, but a picture is worth 1,000 words. So let's move on. LRS, or locally redundant storage. Your backups are you're going to have at least 3 copies of your backup, but it's going to be in a single physical location. So a single data center, essentially, even if you have availability zones in that region. Again, not every database needs to have the highest level of protection. It could be dev. It could be something that is a tier 3 database. So the least expensive option might be good for some of your apps. But if you need additional protection, ZRS or zone redundant is going to copy your backups across all of the availability zones in the primary region. Now, what if you want to use cross-region backups as one of your DR solutions, which we'll talk about in that section? Well, you have 2 options. So for general purpose and business critical, you can use geo redundant storage. So in this case, your backups are going to be in one physical location in your primary region, and will also be in another region or in another physical location in the paired region. So one thing to note here, this does rely on the paired regions being available. You don't get to set up which other Azure region this goes to. The benefit here, if there is a outage in your primary region, you could use the secondary region backups as another copy of your database to restore from. And if you're using hyperscale, you have this option to use geo zone redundant storage. I definitely had to include a copy of this because the text or the picture of this because I think the text is confusing. So here, your backups are zone redundant in your primary, and then they're copied over to the secondary where they're locally available in the secondary. So you have options when you set up your database. Again, for hyperscale, currently, this backup redundancy is chosen at create time and can't be modified after. So this is where you choose it. Like it's an option in the portal, right? When you're setting up either business, if you're choosing business critical or general purpose, you'll see backup redundant, backup storage redundancy here, LRS, ZRS, GRS. When choosing hyperscale, depending on if your compute is zone redundant, determines whether or not you can use zone redundant backup or geo zone redundant backup storage. These are also options when you're creating your database via PowerShell, via CLI, and REST API. Yes. Oh, okay. So that's the fundamentals are our backups. A reminder, the backups are taken automatically. They are stored in a Microsoft managed storage account, and you have the options on what types of storage to use for them in terms of redundancy. And in this case,
quick question,
as we know, yes.
Before you do recovery, is that for both managed instance and Azure SQL DB?
The the redundancy?
Yeah, they asked right on that last slide.
Okay, yes. So again, with the general purpose and business critical, managed instance does not have the hyperscale tier, so that would not be applicable, but the other things are, yes.
Perfect, thank you.
Yeah. All right, so now recovery. So a backup is only as good as its ability to be restored. Now, I feel like being a Azure SQL DBA is a little bit easier when it comes to restores than it was being an on-prem DBA, because I no longer have to go through a script or just a series of backups to figure out which ones to restore. I simply choose, for a database that's already existing, I need to restore to a previous point in time. All I have to do is figure out the point in time. SQL just figures that out for me. If I want to restore backup of a database that was deleted, I just choose that database. It restores it for me. I don't have to do the legwork of figuring out full backup differential. How many transaction logs do I need to stop at? Like, that's all done for me. And restores can be done, again, in the portal, but they can also be done in a code-based approach. So PowerShell, CLI, etc. So some common restore scenarios. So say you already have an existing database and you have something like that initial, most common thing like a data entry error. Here you can restore the database to the same region and the same logical SQL server, and it is given a new name. So much like on an on-prem SQL server, right, an instance you control, you can't just have two databases with the same name. So you're going to have a new database with a new name, and it will put the data there in as it was in that point in time. Perhaps you then take and delete the existing database, and then you rename the restored one to the previous name. Might be a case if you just need to start over. If you need to move data between those two, you're going to need to take a code-based approach. There's no like built-in data sync between two databases, though. If a database is deleted, again, on purpose, could be accidentally, could be maliciously, as long as it is still within the retention period of that 1 to 35 days that was provided, the database can be restored to the same region and the same server under the same name. You also have the ability to restore a deleted database to another geographic region if you had geo-redundant storage or geo-zone redundant storage enabled on the database. And if you have long-term retention enabled for a database, you can restore that database from a specific long-term backup. Again, these are the full backups to a different server under a same or a different name. Here's my hot tip for restores. There's a lot of different factors that are going to affect how long it takes to restore that database. The size of the database, the amount of compute that you give to it when you create it, how many transaction logs there are, network bandwidth across regions, number of concurrent restore requests going on in that region. So what I tell people is, say that your database is typically 4-core general purpose. If you need to restore that database quickly, create it as a 16-core. You're giving it more processing power to go through a little bit faster. And then, also equally important, when that restore is finished, scale it back down to its typical 4-core and continue on. You'll be charged for the extra cores during that period of time, but it might be helpful. Question?
Yep, we got a couple on restores. Okay. It says in the past, you cannot replace a database with a restore with the same name. Is that now possible?
That is not. So same thing where if the database already exists, like AdventureWorks, and you need to restore it to a previous point in time, it's going to be restored as AdventureWorks _ and then the timestamp, or you could change that name.
Perfect. Does Azure Backup Restore offer object level recovery?
No. So this is, again, the same SQL engine that you're already used to. So we do not have object level recovery within any version of SQL. I know I've been asking for that for years myself.
That would be super nice.
It's a hard problem to solve.
We've got a couple more questions if you want to take them at this time, or I don't know how you are in time.
Let's get through the demo. I want to do a quick demo of a point in time restore. I'm just going to use the portal so you kind of see the options. But once I get through that, we will pause for just a moment for questions. So I here in my Azure subscription, I'm looking at my, again, logical SQL server. Remember, databases are at the SQL server level, and under not under settings, under data management, your backups, those backup containers are also tied to your SQL server level. So number one thing here, if I had a deleted database that I needed to restore, I could find it there. More commonly, of course, we're going to be taking an existing database and saying, someone did an oops, I need to restore to 8 o'clock this morning or 10 o'clock yesterday. So in this case, we have a restore action. And what I want people to note is that when I do this, you'll see the dialog that comes up is create SQL database. So when we do a restore of an active database to a previous point in time, it's creating another SQL database. Note that it puts it in the same subscription, puts it in the same resource group. It chooses the source. Yeah, obviously I've chosen my source database. I could choose here point in time or long term, but we're talking about point in time. It's going to show me my earliest restore point. For this database, I have it set to the default of 7 days backup retention. I choose that I want to go back to yesterday. It's going to be in UTC. I know it was early morning, so I'm going to do 10. No. I always forget about the AM, PM. I shouldn't. I do. And then you'll notice here's the default naming convention, Wide World Importers, 8/7, 10/15. So it's just taking the time that I am restoring to, restores it to the same server. And now I'm at the point where it's allowing me to just configure this like it's a new database. Is it going into a pool? What compute and storage do I want? Am I changing my TDE management? Am I changing my backup storage redundancy? In this case, I'm not going to change anything else. I'm just going to go ahead and create. I just wanted to show you that experience of it's showing you the ability to create a brand new database. We cannot overrate the existing. If we were to do this code via code, right? So in PowerShell, use the get AZ SQL database commandlet to get our source database, which in this case was, cannot double click to highlight things, wide world importers. And then we use the restore AZ SQL database commandlet with the from point in time backup command. Pass in our point in time, pass in resource group, server name, target database, and then where it's, what the default resource ID was. These are the basic commandlets we would want to use. Or parameters. Remember, you could also pass in something like a different geo redundancy or a different compute level. And here's how it would look in AZ CLI. So we use our AZ SQL DB restore command, give it our destination name. Here you can see I'm choosing an addition like general purpose. Could have been more specific in terms of the amount of cores that I wanted, for example. But again, resource group name, the server name, the time that I'm restoring to. So I'm going to pause here for until 11:20. Suggest we have, if needed, suggest we have any other questions right now.
We do.
Okay.
Is it possible to restore between different subscriptions within the same region? So we need to restore between environments to refresh data from prod to test in different subscriptions.
It's not with the restore command. To get a database to move between subscriptions, we need to go into the database. No, I don't want to go. Yep, resource group. SQL Server. And what we can do is we can, go to the database. I promise I know what I'm doing. I'm nervous. I'm nervous presenting at 8KB for my first time. For any of you wondering, is this nerve-wracking sometimes even for experienced presenters? Yes. One of the things we can do is issue a copy command. So if you need to move a database to a different, say, a subscription, you would use our copy command. You can also use like the export to create the backpack file and import that somewhere else. Lots of caveats on that that I don't have time to go into today.
No, that's perfect.
Another question.
Yeah, Rob
I'll take
has
one
also
more.
sent
I'll take
a
one more
hug.
on restores.
Not a question, but a hug.
Well, thank you.
One more question was, is it possible to copy the database backup to on-premise for offline backup? If so, is it available for all types, general, business, hyperscale?
It is not for Azure SQL database. So for Azure SQL database, all three tiers, backups are fully managed and fully protected. If you are using Azure SQL managed instance, either general purpose or business critical, there you do have the ability to take a copy only full backup into your own Azure storage account. And that could then be moved off or out of Azure into, say, on premises. Data egress charges would apply. So SQL DB, no. SQL MI, you can do a copy only full.
Perfect. Thank you.
All right. So we've covered backups and restores, which are, again, that most fundamental part of making sure our data is safe. But sometimes we need to ensure a really quick, recovery time. How can we ensure that a database and all of its data is available in our primary region in the event of a service interrupting option? Maybe not data deletion, but just server unavailability. That's what we're concerned with high availability. So again, one of the best things about Azure is, as a DBA, I never have to configure an availability group in Azure SQL database. The downside is I don't really get to choose what my availability options are. The high availability, so when we're talking about high availability, what I am going to be talking about in this section, you'll notice I'm not worried about other regions. I am only concerned with what is happening in any one region and its availability zones and its data centers. So we're zooming down a little bit into this one part of our Azure architecture. Again, high availability is built in for Azure SQL Database and SQL Managed Instance. The level of availability you are going to get is based on which tier of service you choose. So general purpose, business critical, or hyperscale. One thing I do want to stop to talk about first a little bit more, though, is those availability zones. So when I was on that earlier Azure architecture, I showed the availability zones, at least 3 in the regions that have them. Again, the benefit of an availability zone is that it is geographically separated from, the data centers in an availability zone are going to be geographically separated. They're also going to have different power, different cooling, different networking, different security. So if there is a very local interruption to a data center, right, you could kick over to a different availability zone. You can set up availability zones for your compute, right? So your actual server that's provisioned, if it's in business critical, like you can set up an availability zone so your compute is set across zones. But by default, that's not the default yet. You can also set this up for things like your backup storage. Again, the benefit of availability zones are your compute and storage are in multiple data centers in the same region, but independent of each other. This really reduces that single point of failure during an outage or a disaster. And something that I do mention occasionally to customers where there are very specific data generation and retention laws. I think things like the EU, if there are data residency laws and you need to achieve a level of DR but cannot move your data outside of one region, choose a region with availability zones so you have at least an additional layer of protection. So we choose if we are using an availability zone for our database during our creation. So you can see with general purpose, do you want to make it zone redundant? Yes or no. For business critical, make it zone redundant? Yes or no. For hyperscale, make this database zone redundant? Yes or no. Now, let's move into the actual high availability tiers. Question.
Are you asking me for if there are questions?
Was there a question? I saw.
Yes, there is. Oh, it
okay.
Pops up. Okay. Does the
yes?
DBID...
I see like one little quick icon, and I'm like, oh, what's going on?
Gotcha. Does the DBID of the database change when going from one zone to another? The reason I'm asking is because we have a vendor that uses the DBID to craft its security for users, and if the DBID is different, the process will error out.
That's a great question that I don't know off the top of my head.
I'll pop it in the notes.
Please. Yes, I will look that up. All right. So let's take a look at our actual high availability. architectures. So let's start with general purpose. The closest thing that I am going to compare this to is a failover cluster instance. It is something where you're going to have a compute node, and the compute node has remote Azure storage. So this is still Azure Premium storage for your logs, right? You're going to have availability at that storage level. So now let's say that there is an issue with your compute node in this region. In that case, there are nodes with spare capacity, and your SQL server.exe process is started up on another node with that spare capacity and points then to the same data that you had in storage, which has multiple replicas. So that's also protected. So again, kind of like a failover cluster instance where one copy of the data node could go down. You have to spin up another one to make it work. The data in your premium storage, of course, is replicated multiple times. A couple of things to note here. This is going to be a little bit slower of an RTO because that, other node has to be started up. It is going to have a completely cold cache because it's not going to have any of the data you've been reading in memory. And you can't set up readable secondaries here. So let's compare that then to the next tier, which is business critical. Business critical is essentially an always-on availability group underneath. You're going to have at least 3 compute nodes in the same region. If you choose availability zones, they're going to be spread across those availability zones within the same region. In business critical, you have your compute node and it has locally attached SSD. You're going to have at least one synchronous secondary within the same region. If there's an issue with your primary, if for any reason that compute node becomes unavailable, again, availability group, it's going to fail over to the fully synchronized secondary. So this is going to be faster failover than the general purpose tier because of the nature of the always-on availability group. Another benefit you have is that you can use the secondaries as readable secondaries. You have the option to set your read intent in your connection string to true. One question I said before I was getting started that I was trying to add in some information that I got about questions that I got this week. Someone had asked, can I set if I set, read intent equal to on, will it always guarantee that it's reading that synchronous data? And that actually says in our documentation for the failover groups that we cannot guarantee that. So that's interesting to note if you're using business critical and your application requires that you must have the most recently committed data at all times. Do not use that read intent equal to on, right? That read intent could potentially be behind in transactions. And I've put that in my resources at the end because I thought that was a really interesting question I got asked this week. Jess, do we have questions?
We have one about licensing, if you'd like a licensing question.
Ooh, let's save that till the end.
Okay.
That I am not here to answer because that will totally throw me off my track. All right. And then last but not least, the hyperscale tier. I think hyperscale is incredibly cool. So again, it was built as kind of a distributed architecture. I'll show a picture of it on the next slide if you've not seen it yet. There are 4 different pieces to a hyperscale deployment. There's your compute, which runs the SQL server.exe process, has your local cache, that sort of thing. A hyperscale system then scales out reads by putting RBPXX, the like remote buffer storage, on page servers. This enables massive read scale out. We've also decoupled the log into its own service with its own compute. And last but not least, we have that database file storage in Azure Storage. All four of these levels, all four of these pieces have their own built-in redundancy. So let's go ahead and, again, a picture is worth 1,000 words. Let me get out my fancy laser pointer and talk about this for a moment. So here is our first level of storage, our compute. By default, we create our primary replica. Again, this is running SQL Server.exe. This has some of our local cache. When you create a hyperscale database, you can choose to create a high availability replica. And this is exactly what it means. And you can have actually up to 4 of them. So this high availability replica is what would be failed over to in the event of a service impacting event to your primary. Again, you can set up to 4 of them. They can be read only, just like in the business critical tier. Now, your log service, that's where the transaction log runs. So that's using Azure Storage. Again, within Azure Storage, we're using premium storage. We're storing multiple copies for availability and redundancy. Same with that base level of the Azure Storage for your data files, the snapshots, the log backups. That additional scale is achieved by having this concept of the page servers. The page servers, so when data is read by the SQL Server process into storage, it's actually put on this page server level. This can scale out to many, many different page servers to help handle those reads. And every page server has its own replica. So if there would be an issue, you're not going to have to like reread that data out of Azure storage into a new page server and like lose that IO. It's already there. So this is an incredibly resilient architecture for apps and databases that need high IO, and you have just so much flexibility with it. And I've always said I'm going to create a session just on Azure SQL Hyperscale. Not done it yet. Maybe this is the year. So that's a look at high availability. Again, there's not anything that you as a DBA or a developer can really configure about these things. The service tier you pick is going to determine what you get. At best, you can use, the read intent to do read-only replicas for business critical and hyperscale. Now, this high availability architecture being baked in is great because, again, if there's a hardware error or a networking error, that failover will take place. But this is also in place so that all of those automatic upgrades that Microsoft does as part of that managed service can be done seamlessly. These are things like, if there are any OS updates, any SQL updates, any, security patches, anything like that. If you set up a maintenance window, right, it occurs in that maintenance window. But anytime that maintenance is taking place, it's going to fail over between these replicas. So that's why I tell developers and tell DBAs to tell their developers when using Azure SQL Database and Azure SQL Managed Instance, use retry logic. Just make sure that if anything fails, it is retrying, because there will be failover between these high availability nodes in any tier to achieve that true managed service. with that, I'll stop for a moment and ask, do we have any questions about the HA?
None currently.
Okay, can you throw that licensing question at me now? So since I've got the hyperscale out of my brain.
Sure. So this was asked on the general purpose slide, and the question is, since there's no readable secondary, SQL licensing terms and price are different than the on-premise one? Question mark.
Well, I mean, pricing and licensing for Azure SQL doesn't work the same as SQL on-prem anyway. The person that asked that question, if you want to talk about that a little bit more, like please send me a message on LinkedIn, and I would like to dig into that a little bit more. That's a whole topic.
Yeah, for sure.
Okay.
Cool. We got one more that's coming while you're answering that one. And that says, with multiple copies of the transaction log in hyperscale, when is durability achieved? After the acknowledge of the first successful write, and what about delayed durability?
Reread that again, please. So it was hyperscale, correct?
Yes, it just disappeared. Here we go. With multiple copies of the That's right. I was like, it was just there and it's gone. With multiple copies of the transaction log in hyperscale, when is durability achieved? Is it after the acknowledge of the first successful write? And what about delayed durability?
Let me answer that question afterwards. That is not in my plan cache at the moment.
No problem.
Okay. And with that, I also want to get on to our last topic before we run out of time, which is disaster recovery. This is the part that deals with going across regions now instead of just focusing on one. And compared to high availability, right? Disaster recovery is absolutely something that you can configure. So when we talk about having our data available in multiple regions, there are three options. Those geo-replicated backups, which I've covered a little bit, active geo-replication, which is a per database feature, and then a failover group, which is one or more databases that are on the same logical SQL server. So a couple of things that I want to note as like the most important things about each of these. If you need automatic failover groups are the only option that offers that. If you want things to be automatically behind load balancers so that apps do not have to update their connection string, failover groups are the option that gives you that. Can it be set up between non-paired regions? You can do that with active geo-replication and failover groups. If you have multiple databases that need to fail over together or be restored together, right? Like you can't restore multiple backups together. Geo-replication is one database at a time. Failover groups would allow you to put multiple databases together. So let's talk about the basics of these. So restoring geo-replicated backups. As I mentioned earlier, you already have to have your database set up to use either geo-redundant storage or geo-zone redundant storage. So when you have these options set up, right, your backups are copied from your primary region to your secondary region asynchronously. The RPO is up to 1 hour. So one big difference between restoring a backup within the same region and restoring a backup in a secondary region is when you go to do a geo restore, you do not get to pick a point in time. When you are doing a geo restore, it is to the last point of that most recently replicated backup file. So just again to stress, you don't get the option to do a point-in-time restore in a different region. So again, your recovery point is going to be up to 1 hour because of the asynchronous nature of the file copy. RTO, docs say, usually takes less than 12 hours. It could take longer depending on size and activity. Again, geo-replication depends on those paired regions. If a region or the Azure SQL service or the storage service in a region is unavailable, there are a lot of people going and a lot of customers and a lot of databases going to activate their databases, their applications, do their failover into the paired region. So in the event of a service outage, it can take longer than you would expect on a non-impacted day. Geo-replicated backups, again, absolutely viable as a disaster recovery option. Understand your application and your data's RPO and RTO to make sure that this fits as an option. And just like any other backup, you can do this in the portal. You can do this via PowerShell. You can use CLI. You can use the REST API. When you do this, again, you have to have an existing SQL server in your secondary region, and then it's going to restore it as a new database in that region. So now let's compare that to what we call active geo-replication. So this is set up again at the SQL database level. So one database at a time. This is going to be just asynchronous, like constant asynchronous replication of the logs from the primary region to the secondary region. One of the nice things about active geo-replication, you can create up to 4 readable secondaries and put them in different regions. So if you need some read scale out and the readable secondaries do not have to be within the last 5 minutes. If they can read data that's an hour old, 6 hours old, a day old, reporting, that sort of thing, and you want this as a resiliency option, active geo-replication can fulfill both of those needs. Now, one downside here is that the failover is always going to be manual. I shouldn't say a downside, just it's the feature of it. So if your primary region is impacted in terms of availability, and you want one of those secondaries to become the primary, you, the DBA or developer, must do the failover yourself, choosing which server to fail over to in which region. And because you're now pointing your app to a different database on a different server, you're going to have to update your application connection string. So what that looks like, right? You're going to have your primary in your primary region. You're going to have your secondary in your secondary region. There's nothing automatic here. No load balancer involved. Again, I want to emphasize that we're doing this at the database level. And we would, going into SQL database, we would see replicas. So I'm going to pop that open here and just take a look at this. So here I am now in my wide world importers database. So not at the server level, but at the database level. If I go here to data management replicas, nothing exists yet, but I can create one. So let's take a look at what our options are here for the geo replica. We're going to be using the same subscription, primary database, secondary database. Okay, so it's going to use the same name. The server, though, a database with that name already exists on the server. You know what? I did this recently, and I'm going to go to a different database. I did not clear out my replica from a previous demo. Okay. So now my Communications USA database. Let's create the replica. Time for me to clean up my test Azure subscription here. And a database with, all right. So let's create a new SQL server. And our server name is going to be SQL 049. And this one I am not going to move into a paired region. I want to show you that the source database is in East US. So I'm going to say West US, right? And then my location, I'm going to choose West US 2. For authentication, what it's doing is creating a whole new server. So I am going to set myself as the Entra admin. Don't worry, them changing the Active Directory name to Entra does not mean that I am going to remember to say it differently at any point in my life. Okay. All right. So now it's going to be creating a database called ComUSA on the server SQL 049 West US 2 in the West US 2 region. Again, it's creating a whole new database. So it's going to ask me all of the traditional things like, do I want to use a pool? What compute and storage? What backup storage redundancy? And I can go through all of the other settings and create. So that's how easy it is to create a GeoReplica. Again, proving that it does not have to be in a paired region. And again, per database, you can do this 4 times. So while that is deploying, I'll talk through just a couple more things like why we would use this. This can be really beneficial for especially cloud native apps where you have one app, one database, or maybe an app with a microservices architecture where the databases aren't grouped together, right? They're not talking to each other, that sort of thing. Again, useful when the app could benefit from readable secondary replicas, particularly those where the data can be a little bit behind, where it's okay if it's asynchronous. And this would also be good for an app which has a high enough RTO to allow for manual failover to the replicas and time to update the connection string. Oh, so there was my demo. I've got that going already. Jess, any questions about this right now?
Not currently.
Okay, so if I go back to my resource group and sort by type, if I look at my SQL servers, you'll see not only do I have East US 2, I also have my West US 2 server deployed, and no database found here yet. Going back to East US 2 and going back to my ComUSA database. You'll see that it is currently replicating and seeding the replica into that secondary region. When it is available, we'll be able to do things like failover. So we'll give that a moment. One of the joys of doing not pre-recorded demos is waiting while the demos finish. So let's contrast active georeplication with that last option for disaster recovery, which are failover groups. So just so you understand, failover groups are just an abstraction of georeplication. It's the same technology behind the scenes. A couple of differences. It's set up at the server level. You can have one or more databases grouped together that can all fail over together. Big difference here is that the readable secondaries are behind a load balancer with a listener. So that's really great. You, through the portal, can get either a read-write listener or a read-only listener name to connect your app to. The failover can be automatic or manual. I'm going to talk about that failover policy, as we call it, on the next slide. And big differentiator here from active georeplication is if you're using those listener names, you don't have to update your app connection string in the case of a failover. So the failover policy, there are 2 options. The names were changed a few months ago to indicate just a little bit more clear on the responsibilities. So there's customer managed failover and Microsoft managed failover. In your on-prem SQL environments, if there is an outage of your primary region, do you have some mechanism that just automatically fails databases over to a secondary region? I never did. I don't work with customers that do, right? If the primary region is impacted, there's generally a set amount of time. We would wait to see if it can be brought back up. And if not, then we would bring our DR playbook and failover apps, failover databases. That's what a customer managed failover will do. Your database would be unavailable. Your failover group actually in the databases and it would be unavailable. You choose when to do the failover. There is also a Microsoft managed failover policy. So here at this service level, right, there's a failure of some sort that cannot be fixed by just using the built-in high availability. When you choose Microsoft Manage, you have to choose a setting called the grace period or your failover period. It's a minimum of an hour. It can be set up to, I think, like 24 hours maybe. And what happens is when this service fabric, like this automatic system in place, determines that this event has happened, right? Like high availability is not good. Say it's at 11:30 a.m. It will not start the failover until at the earliest 12:30 a.m. So then if you have this set, that's going to then fail over all of the databases in the failover groups in that region. And one thing to note is that after this Microsoft managed failover, read-only listeners are disabled to avoid impacting your new primary. That's a setting you can change. So this is, again, the customer managed is recommended because it allows you to choose when that failover group is moved over. And you're managing the read-only secondaries. Microsoft Manage can be good for databases and groups of databases where you are willing to say, after 3 hours, yes, just let it fail over. We want that automation. What you'll notice here is the difference is that there is a load balancer. Again, so we have our asynchronous replication from our primary to our secondary, but here there's that load balancer, which is able to take both read, write, and read only. So again, this is managed at a Azure SQL Server level, where you would go to failover groups, choose to add a group, and then add multiple databases to it. There's a whole dashboard built into the portal that allows you to see what databases are in the group. You can do your, forced failover or a synced up failover. And why do people choose failover groups? Again, your application may have multiple databases that need to fail over together, or your RTO is low enough that you want that automatic Microsoft managed failover. Your connection string can't be updated manually. So I'll pop into the portal here and first off, check on our replica. Okay, so now for our ComUSA SQL database, we have a replica from East US to West US 2. You'll notice that it shows the ComUSA in East US 2 as online, the ComUSA in West US 2 as readable. And this is where we can do things like do a synced failover or do a forced failover, or we can stop replication. As I mentioned, though, to set up a failover group for multiple databases, we need to go to the SQL Server level And this is where we would go to failover groups. This is where we create our group. I'm going to create that off my East US 2. Oh. I'm going to set this up for the Canada and Mexico databases and select. And we'll just go ahead and let that create. So I'm going to stop here and I know I'm right at the end of my time. So Jess, are there any quick questions that I could answer right after? And if not, I can pop into the SQL Slack also after this and continue to ask or answer questions there.
Yes, there are a few questions that have come up
Okay.
on failover groups and stuff. One is for failover groups, what's the load balancing method? Is it round robin or load based?
It is not route. So for failover groups, you're going to have one. That would be more of a question for the, like you're not, I'm stumbling over my own words here. In a failover group, you're going to have your primary, you're going to have your secondary replica. This is not going to have like multiple replicas in the second region to do like load balancing round robin with. Like either you're going to have your read write go to your primary and read only go to your secondary or not. Like it depends on which endpoint you're going to, but there are not like multiple read replicas in the secondary region to do that offloading to.
Yeah, cool. Okay,
Yeah.
I'll pick one more, and that is
okay.
Can I have a readable secondary in another subscription for like a migration? So 2 in one sub, and then add one in another sub, and then you would turn that into the primary and remove the others.
I don't believe we can do any of this cross subscription currently.
No problem.
Yep.
Awesome.
All right. Well, I had some great questions today, so we will not get to see the final of this deployment. I should have had that one done, lesson for next time, but let's just do a quick recap here again. Backups are the foundation of your DR strategy. Azure SQL Database is going to be taking those backups automatically. You get to choose if you want them stored in one or more regions. The restores are very simple to do. You can do point-in-time restores of existing databases, restore deleted databases, restore to a different region, and you don't have to figure out that whole list of which backups to restore. High availability built into every tier, and disaster recovery, you have 3 options, either the geo-replicated backups, geo-replication for a single database, or failover groups using geo-replication for multiple databases. So with that, I will say, thank you everyone for coming along on this journey with me. I hope you learned something. I don't think we have time for more questions, but I will again hang out in the SQL Slack channel to answer them in there for about 30 minutes. And to the organizers, thank you for having me today.
Thank you for coming. That was amazing. It's such a vast universe of technologies and capabilities in Azure to be able to build those complex systems that you made so very approachable. So thank you so much.
You're welcome.
That was absolutely fantastic. I actually do an on-premise version of DR strategies for SQL Server. People keep asking me about the cloud, and I don't really know much. So thank you very much. I can now just direct them straight to that set.
Yes, until we introduce something new in a few months, and then I have to go back and re-record it again.
Okay,
yeah,
everyone.
The thing that always got me was portal updates. I'd get all the screenshots and the videos, and the next thing you know, the portal changes.
Yes.
That's coming from someone who does a Pluralsight course on Kubernetes.
Yeah, right. That doesn't change fast.
Okay, so thank you so much, Jess. That was fantastic. Absolutely brilliant. One thing, we have an announcement, everyone. Unfortunately, the final session of the day, our speaker has had to drop out. Our Janice won't be able to do his session on LLM internals. So what we're going to do is, for everyone who's registered, he's going to contact us when he's back and available, and we will send out a link to do that session at a later date to be determined at this moment, I'm afraid. So we will be finishing off one session early this time around, but we still have 2 fantastic sessions to come. I can see Deborah's here. Thank you very much, Deborah. Been here for a while, so my blood pressure has been great for the last little bit.
Yeah, and I'm just presenting, and I can't imagine what y'all are.
I was making fun of Robin Slack for not doing his job, and I only have one job, and I'm not doing it.
You only have 73 jobs, Andrew. Come on.
There we go. So yes, we have a whole answer. We have all the resources there: the GitHub, the YouTube, the web, the Twitter, the email, the Slack, the event feedback, and the store there. We've noticed some people have been buying t-shirts. Thank you so much. It helps us pay for basically the Zoom registration and the emails that go out, so we can keep continuing on putting these events on. Next thing is please do leave feedback for Jess. Please tell us what you liked, what you didn't like, and we will send that out to the speaker after the event. So I'll leave that one up for a little bit so people get time to grab the link, grab the QR code, and go in and leave their feedback. And then we will be kicking off with the next session with Deborah in a. Am I doing my timing right? It's 8 minutes, yeah? 10 past.
That's what I see.
Excellent stuff.
We're not going to talk about me in time zones today. Fixed them yesterday.
Every year. And I'm not making fun of it, because if I did it, it would be an absolute disaster. So time zones are hard. Okay. Let's see if we've got feedback coming in. No expense spared on the feedback. Literally. Yes, we get feedback coming in, so I haven't messed up the feedback links, which is.
Hey, Andrew, if you can adjust the feedback link, that URL, that second backslash actually leads to an error.
Okay, well, really?
I just manually typed it into a browser and it gives me a 404. You need it without the second backslash.
Thank you very much. We're all big on QA at 8KB, as you can tell.
Testing in production. Still testing.
100%. How are we all doing? Everyone's mind still good? Not melted completely?
Well, we have a chance of survival now that unfortunately our Jonas had to bail.
We might get through the day without being completely melted, yes. But as I said to everyone, he will contact us, and we will get a 8KB Part 2 out at some point, to be determined, but we will get that session done. He's promised that he'll come back to us, but it's just unfortunate. Things happen, so it's no bother, but we will get that session done at some point. There we go.
I mean,
and that's the wrong
I don't want to put you on a spot, Claudio, but you said you had more demos. I'm totally kidding. Totally kidding.
But yeah, you could come back at the end of the day and do the rest of your demos.
That's mean.
Maybe I can open the hexadecimal thing. Just open it, not doing anything else.
Yeah, well, yet to have someone say they don't like burritos on their feedback forms, so.
Don't you just delete all those anyway? The ones that say they don't.
Yeah, pretty much.
You had to say it now, didn't you? That's it.
It's a good gauge to whether or not the person filling out the feedback form knows what they're talking about. If they don't like burritos, their response is invalid and it gets kicked out.
Well, that just seems silly, though.
It does when you think about it, but hey, this is where we are. We have to right. Well, I'm going to stop sharing my screen, Deborah, and you can grab the screen.
All right. We want screen 2. All right. So y'all see the.
Good.
Good.
All right. Oh, I'm just trying to find where my mouse went. Here
It's
somewhere.
right there. Right there.
Yeah, it's still not showing. I can't find my own mouse. Let's see if I go off somewhere else. Maybe if I go to Management Studio. Okay. Y'all see Management Studio now?
Yes.
Yep.
Good.
All right. Now I see my mouse. Okay. Yeah, I did a presentation the other night in my Management Studio completely blocked on me. So I had to like switch over in the middle of the session. Hopefully that won't happen today. Yeah. Now the awkward pause before we begin.
Ah, yes. Wait for everyone to go get their cup of tea, cup of coffee, vodka, whatever that takes their fancy, Anthony.
Yep.
Is this a good time for a dog cameo just to kill a few minutes?
Always appropriate for a dog cameo.
Bastard, come here. He's sleeping on the chair behind me.
You woke him
Sebastian.
up. Jeez.
He has a WTF look on his face.
That's usually normal though.
Yeah, I'll give you a cat as well. Oh, go on then. Go down there.
Yeah. He's normally camera shy, at least, unlike a lot of people's cats. He's normally camera shy.
I think he wants to go back and nap.
That was
Sounds
last
right.
year we had Josephine and what was the cat's name? Was it Mango? Made an appearance halfway through the session, if I remember correctly.
Oh yeah.
That was funny. Just cat came in. Yeah. This is my house, you know.
My house, my session.
Yeah.
Sorry, a calendar. The cats of 8KB.
All right, we've got just under a minute. What I'll do is when it hits 10 past, I will introduce you and then you can take it away. The only reason we do this is for the recording, so it just looks like it. Take a Okay. Hello, everyone, and we are now on to our third session of 8KB 2024 with Deborah Melkin and Mine Statistics for Data Insights. Please take it away, Deborah.
Thank you. So Andy Yoon is going to be our moderator. So if you have questions, please put those in the chat, whether it's in the Q&A for Zoom or in the Slack channel, and I'll try to get to those towards the end. I feel like I've been running long with my demo, so I want to make sure I cover everything, and then we can answer everything and talk about all those fun questions at the end. So for those of you who don't know me, my name is Deborah Melkin. My pronouns are she and her. I've been working with a data platform for well over 20 years, but this is not a session where we're doing math, at least about that. I mainly work with SQL Server and transactional systems, although I've done a little bit with the other database platforms and marts and warehouses, just enough so I can do damage I'm one of the new co-leaders for the Data Platform WIT user group, so I'm really excited. We've got a lot of fun things going on and things planned, so stay tuned for that. Of these other things, I also want to quickly point out that I am a Microsoft MVP, which means I'm recognized for the fact that I love to get out here, speak on these topics, geek out with y'all. So I'm very honored and humbled for that. But this is not the important stuff to know about me. The important stuff to know about me is I'm a longtime member of my alto section in my choir. I try to go to bluegrass jams regularly, although lately it's been kind of when I'm available, but they're a lot of fun. As part of that, I've been learning guitar, I've been neglecting a mandolin, and the other thing is I'm kind of a musical theater geek. I'm super excited because tonight I get to go see Kristen Chenoweth in a pre-Broadway show by Stephen Forrest. It's gonna be awesome. And when I'm not doing any of that, my husband, Andy Yoon, our moderator for this hour or this session, and I like to do geeky things with our dog Sebastian, who you already saw make a cameo. So what are we here to talk about really? There's a bit of a backstory to this session. So I was working on a project at work that required me to do some data profile and data quality information on multiple tables in our database throughout different informational domain, functional domains within our system. And so I went through, I did that. And then a little bit later, a couple months later, Andy was working on a session about statistics. So he pulled up Aaron Stelato's session from this very conference, 8KB, and we start watching it. And as I'm sitting there listening to it, something about these two clicked, and I had an idea. Could I have used statistics to get the data I needed for that project? Would this work? Let me think about that. Well, in fact, let's create a whole session about that. So we're going to go through and test that theory out. So how are we going to do that? First, we're going to understand the basics of statistics. What do statistics contain? We'll think about how they're created, how they're updated. We'll kind of take a look at what it means when we see statistics as part of a running workload. So not just the individual statements, but throughout the entire system as everything's working, as you have your day-to-day production workloads going. And then we're going to see how we combine statistics data with other metadata through the system to really answer some of the questions or start answering some of the questions we want to know. Couple things for terminology, more to level set, not that I'm going to harp on these, but these are kind of the driving principles behind what we're going to do. The first one is data profiling. So it's the process of examining and analyzing and really kind of create those summaries of our data to understand what do we have. So it's really trying to also look at data quality issues and risks and trends. So we want to see, what does our data look like, and is it good data? Which leads us to the concept of data quality. So here we're measuring how well our data set meets a series of criteria. We have accuracy, we have completeness, this is a very important one, validity, consistent, uniqueness, timeliness, and fit for purpose. So it's kind of critical when we think about data governance within our organization. And yes, I just said the words data governance. So now before they fumble and try to, I'm going to defend myself, because governance is not something we think about with internals. But when we think about the information we have, statistics, the idea of thinking, does it give us a clue on what completeness is? What are anything about uniqueness? These are definitely things that we can get from statistics, I believe. And when we think governance, it always seems like, oh, it's not just where your personal information lies, that personal PII information, your PHI information. It is about understanding your data. It is understanding the distribution of your data, where it is, how it's getting used, and really great those bigger overall data insights. I mean, yes, the project I was working on was part of the data governance group, but it is still at the core understanding our data from a holistic level. So that's what we're going to go with. And really, that's what we're thinking of. We're not going to think about it in terms of performance, although we need to understand those impacts, but we're thinking about those insights that we can get from knowing our data, the same metadata that SQL Server uses for performance, to see if it tells us other information as well. So why do I want to look at statistics for this? First of all, statistics summarize the data of our tables. Plain and simple, what's in our tables? What is it? How does it look? Now, why would I want to look at something like statistics rather than indexes? Because there's a really big misconception about indexes and statistics. The two are not the same. Kendra Little has a great blog post that I have in a resource later that you can read. I highly recommend it. But when I was reading it, what really clicked for me is the difference between the two. Indexes say where to find the data. It's about the where. Where is your data? Where are you grabbing it from? Statistics talk about what is in the data. This is your data distribution. Have statistics that are related to them, but they're separate. They're not the same. You can have statistics on a column that's not in an index, but it doesn't necessarily mean you want an index on that column. That's where we get into performance. But again, statistics saying there's something about the distribution of data in that column that the query engine needs in order to do its job. But again, one is performance, one is distribution. The alternative is to directly query our tables. Now let's face it, who wants to do queries against those production, very, very wide tables with 50 million records to find things like how many nulls are in a single column or in all of your columns in that table? For those of you who are raising your hand, you're laughing at the same time. No one wants to do this, especially in production. What sort of problems are you going to cause? Could you accidentally block a critical process from running and create problems? Why? Because you're trying to find out the quality of your data in your tables. No one wants to do that. You're not going to do that in production or query the table directly in production. I've had a project where I've been finding I've been using a lot of metadata for things. Hey, how many rows are in my table? Go query sys partitions, not the table directly, because I can get that same information from the metadata without bothering anything else that may be going on in the system. So it feels like a safer way to find that information. Let's see if we can get the same sort of thing from statistics as well. And with that, let's head over to Management Studio and let's start seeing what we can find out. So for the demos, I'm borrowing the Stack Overflow database. It's from 2013. Brent Ozar makes this available for his demos in many cases. And for me, I wanted a big database with lots of data. And this was a quick and easy way to do it. Again, if you want to download this yourself, I'll have the reference to Brent's blog post on how to do that as well. But what it does, it's a very stripped down version of the database. As you can imagine, it's got 9 tables, and the only thing in it are primary keys on each of those tables. So let's look at our statistics. I'm going to look at most of my queries, what I'll involve. You'll see that I use the sys stats system view as well as stats column. I'm joining to sys tables just to make sure I'm only looking at tables. And as I said, we can see here, I am just looking at the primary keys for my tables. I've only got named tables in here. Now these have the name of the index that the stat is associated with. You can name statistics. If you have an index, your stat has the same name. But if you're creating separate statistics, they may not. We'll see we have different naming available. So since we have some stats that already exist, I want to talk about some of the things that I'll be using as we examine statistics. DBCC shows statistics, so that's got most of the information that we have. There are also going to be 2 dynamic management functions. They're not DMVs, dynamic views. They're actually functions. One is DMDB stats properties, and one is DMDB stats histogram. Yes, there are some other DMVs that have to do with other types of indexes. I'm pretty much going to focus on the basic, your run-of-the-mill indexes when we look at that in your run-of-the-mill stats, because honestly, that's all the time that I have. And to be honest, that's most of what I work with as well. First thing I'm going to do is I'm going to look at our votes table, and I'm going to show the statistics for that. And we can see there are 3 different data sets that are returned from DBCC. We have our header, we have what's called our density vector, and then we have our histogram. We can use DBCC and we can show just those individual sections, but I'm going to start by combining that with our DMFs, our functions. So properties displays our stat header. So I'm going to show the two of these combined and we can see the data together. Because a lot of the data is the same. Not all of it, but most of it. Our function has the object ID and stats ID. We have the last, while our DBCC has the actual name. Both of them have the last updated. They both have the number of rows that exist in the statistic. For the most part, unless you have a filter, it's going to be all the rows in the table. The next is rows sampled. Right now, our rows sampled equals the number of rows we have in both cases. So what that means is we have a full scan, which means our statistic is based off all the data in the table. By default, an index will be a full scan when it's created and when you rebuild it. Reorgs and updates will result to have it going to a sample value. When you have a very large table and it ends up being less than 1%, but it varies as to what that percentage could be. But SQL Server doesn't need to know everything. It's going to go sample. It's nice, it's quick, but it changes depending on how it's created or what type of stat it is. The next column is steps. This is the number of steps we have in our histogram. I'll explain that in a moment. Now we can start seeing that there are some differences between the two. Our DBCC has density, which says how unique it is, average key length, so how long it is. This happens to be an integer field, so our average key length is 4. String index, is there a string value as part of our index? If we had a filter, if it was like a filtered index or something like that, we would see what that expression is here. Then we go to unfiltered rows, and we don't have a filter here, so the unfiltered rows matches our rows. Otherwise, this would be the full value of the table, and our rows would be the full number of rows for the unfiltered or for the filtered statistic. Our function has a different value, modification counter. As we make changes to our table, we need to know if there are changes that could affect our statistic, and at a certain point, that will trigger an update. And we'll have to update our stats. This modification simply says how many changes have been made, and that will be used for the calculation. We'll take a look at that later. And the last column is persisted sample percent. There may be cases that you want to set a sample percent for your statistic, and there may be cases where you want that to always be the case. If so, that's what you're going to see here. I'm not doing that or going to get into why you would do that here. That's really more for performance tuning, and that's not what this session is. So those are our headers. The next is our histogram. This kind of is where we start getting fun information from our stats. Because what the histogram is our data distribution. And in fact, it's our actual data distribution. So what SQL Server does is it breaks our data down into individual steps. And we can see that here with the step numbers. We get that from our function. DBC doesn't show that information. It kind of assumes that you can figure out that this is the 8th step and this one's the 6th and so forth. The rest of the columns are exactly the same. The first column, range high key. For each step, it says what the highest value is for that step. This is a little harder to read because these are IDs, they're all numbers. But what it's saying is for this first one is the top value in our step is 1. For step 2, the top value is 216530. So this step is made up of all the values that go between 1 and 21530. And so, and this one is, 1 million, 1.5 million, so on and so forth. You get the idea that this is still the last value of that step. The next value is our range rows. This is where it kind of gets a little tricky to describe and it gets a little confusing. It'll make sense a little bit more when we start playing a lot more with this data. But our range row says the number of rows in our step that do not match our high key but fall in that range. So we have 131,000 rows approximately that are not 216530 ID but fall between 1 and that value. Our equal rows says the number of rows in the step that equal our range high key. the order of these columns really need to be switched up so it's not as confusing. The next column is our distinct range rows. So of our range rows, all those values that do not match our high range key, how many distinct values are there? And then we have the average of average number of range rows for everything that's not our high key. So essentially it's our range rows divided by our distinct range rows to get us our average. It's kind of confusing based on what way everything's laid out. We got some examples later that will really clarify this. But we can see we're starting to get our data distribution broken out directly, and we can really see what data we have. The next one I want to show is density vector. And in some ways, density vector is a lot simpler because it's a lot less columns, and it's very simple as to what it is. It is saying for our ID, how many unique records exist in our database, in our table. All density is represented as 1 over the number of unique rows. So you have to do the calculation to get the exact value, but it is talking about what our density is. Average length also goes to how long, what is our average length of the values in our unique columns or column ID. So in some ways it's much simpler because it's not as many columns. I do find density vector a little harder to work with, but it still works out and we can still look a little more and make sure we do figure out what that all looks like. So now that we see what information we have to work with, let's start creating some statistics. This database, I've made sure it's set so auto stat creation is set to true. So when we need stats, it's automatically going to create those stats. I also have it set to when we need to update a stats, auto update stats is also on. So those updates will go through as well. But first, we just have our primary key statistics or the statistics associated with our primary keys created. So let's see if we can get some more and see what information we get. So I'm just going to select from all of our tables because how are statistics created? We run queries. If SQL Server is missing a stat that it needs to create a query, it will add one. So I'm just going to do a quick select 100 from all of my tables. Pretty quick. Let's see what happened. Nothing. Why? Because the information we need from these stats was enough to fulfill the queries. So no new queries, no new statistics were created. Let's fix that. Let's focus on our post table and let's create a query that should generate a statistic. So I'm going to select top 10, some of the columns, and I'm going to look for parent ID equal to 0, which means it's a top level post. So it takes a couple seconds. It's a wide, long table. And here we go. We have our query. Now let's see what happens with statistics. Great. We have our new stat right here. You can tell it's an auto-created statistic based on the name, WA, Washington State, system. This is which column on the table it is, and this is a hexadecimal of the table. So you can actually interpret it, but all you need to do is say, oh, look, underscore WA, SQL Server auto-created a stat for me. Unless you have someone who thought those stats always needed to be created and scripted them out and created them with the new database, but that's a separate story. We'll talk about that later, maybe offline, but we'll talk about that one later. But let's look a little more detail for our posts. So now what I'm doing is I'm going to, again, look at our stats system view, our stats column system view, and now I'm going to cross-apply that with our properties because we have statistics now. We have properties, and by doing this, I can look for everything for my post table all at once because I like being able to do that. Instead of multiple different queries trying to re-get the object ID and the stats ID because you need the IDs for the DMVs, and it's just a pain. So now I can look at everything all together. So I have my additional stat for my primary key, and I have my stat for that was just auto-created. I can see one is ID, one is parent. I can see the different last updated date. I can see the rows are the same number of rows on the table, But now we can start seeing some of the differences. It's an auto-created stat. So we now see it's sampled. So by default, auto-created stats are sampled. We can see they have different number of steps in our histogram because they have different data distributions, and the way it needs to be done breaks out a little differently. And we see nothing for the modification because I haven't made changes yet. Now let's do something. Oh, right. My reminder that I want to look at some of this information, save some of this information for later, because for some reason, my numbers change every time I do this cleanly. Not 100% sure of that, but we'll take a look at that later. Next is I'm going to do the same query, except for I'm going to substitute properties, and I'm going to use my histogram and get that for the entire table. These are probably not two that I would want to necessarily query side by side because the data is a little different, but it gives you a good idea of how you can look at things. Oops. So the first 6 are my post ID. This is my histogram for my primary, associated with the stats for my primary key. And then next is the stat associated with this parent ID. One of the things that we'll note are different is you'll see that things like range rows, these are now decimals because it's approximate. It's based off a small percentage, and it has to kind of guess how much is going to be there. It's not 100%, but it's trying to figure things out. It's kind of close. So we see that things for like range rows, equal rows, these are estimates. And then our, well, average would be an estimate or a decimal anyway because it's an average. But really, you'll start noticing that these are decimals because we're not sure, but SQL Server's pretty sure this is what the distribution is going to look like based on our sampling. Now let's look a little bit at our density. The first thing I do want to do is get this density value here from our show stats. And now I'm just going to run for our density vector. So we have a density here. Well, this number is kind of meaningless written this way, but as I said, what that represents is 1 over that value. So from our sampling, if I run 1 over, there it goes. This is our results. We have 143,049 or 050. Well, remember that this is a sampled data. So it's not, so when we look at percent, this is really based off the unique numbers of the sampled data, not the entire data. It took me a while to figure this one out. So now if I go back, I get my rows sampled. So I have the correct value here. Remove the comma. And if I go for percentage, 0.9716. And if I look at what I got earlier, it's off a little. It had the density on my properties header as 0.96. My math is showing 0.97. I'm not quite sure what the difference is, but for the purposes of what I'm doing, I'm looking for insights. I'm not looking for those perfectly line up. I think this is going to be enough for what I'm looking for because, again, it's off by 1%. I'm going to say that's close enough, but at least I get an idea of where it's coming up with those values from. So now let's play a little more with our histogram. And I think trying to explain what the different columns were earlier was a little awkward. But here, let's do 2 queries that hopefully help explain it a little better. The first one is I'm going to look at the sum of my range rows, and then I'm going to look at my sum of equal rows. If I add these 2 together, I should get the total number of rows in my table. And then in my next query, I'm going to take my sum of the distinct range rows, so the number of unique values, plus the number of steps, because each step represents 1 unique value. And if I combine the 2, I should get my total number of unique values. So I'm just going to run these 2 together, and we'll kind of quickly go through. My total range and equal rows, 17142,169. And if we go back here, 17142,169. Hey, that math worked. And then if I wanted to go to the number of unique rows, 143,048. And if I go back here where I wrote that down, well, the number's slightly off, 143,049. I'm off by 1. Well, if I round out, I'm off by 2. That's pretty darn close for an estimate. For the purposes of looking at data insight, no, it's not perfect, but those are matching enough for, I may be able to get away with that for what I'm looking at. But again, for an estimate, those numbers are pretty close. I'll take being off by 2 rows. Now let's move over and let's start looking at indexing and auto updates and understanding how the changes to our data affects our statistics. So I'm already in the correct database, and so let's take a look at our votes table. And if I look at our indexes, we can see I just have the stat associated with our primary key. So let's create a new one. Well, actually, I'm going to run this query because I wanted to auto-create some stats before I create new indexes. This one takes a while. You know, I'm going to have enough awkward pauses later. I'm just going to get my estimated execution plan and see what happens. Because it takes a while. I'm awkward enough as it is. So now if I run this, it created my statistics. Oops, always hitting the wrong key combo. We now have our statistics that are created. I didn't run my query, I just got the execution plan. But this also goes back to, we have to remember how execution plans are created. What's the steps that SQL Server goes through? It gets the query, it looks for your statistics. First thing it does, it needs those statistics to figure out what the query plan is. So if the statistics are missing, it does that before it creates the plan or before it figures out, oh, there's already a plan for this. Because what if your statistics have changed enough where that plan no longer works? Automatically create a statistic without actually running my query. That's kind of cool. So with that, I can now start looking a little bit more at the stats, and I want to play with that user ID. And we can see that we have, what's that, 52 million rows in this table. Yeah, 52 million rows in our votes table. Our sample is less than 500,000. And we can see that sample percent rate is 0.92. And right now we have 198 steps. What happens if I create an index? And at this point, this is one of those awkward pauses. So I want to remind you, if you have questions, feel free to put those in the Slack channel or in the Q&A. We'll try to get to those at the end. I'm also going to use this as a chance to take a quick sip of water. As takes about 30 seconds or so for this index to create. Unfortunately, I wish there's a way I could speed this up. There probably is, but I'm not smart enough, so I'll have to look at that for the next time. So we have a couple more seconds. But one of the things I'll point out now is I mentioned earlier when we looked at our stats associated with our primary key, we saw those were full scan. When we created an auto-created stat, it's a sample. Now that we're creating an index on a column that created auto-created stats, now the question is, how does that get handled? What am I going to find when this is all said and done? And this is taking a little longer than normal. I'm wondering if, can I blame Zoom? I don't know. Just taking a couple extra seconds. Unless there are any quick questions that you think I can answer in the chat.
Hey, no, nothing at this time, actually. You've been keeping everyone's attention and rocking and rolling, so you're doing good.
Alrighty then. It's always awkward when these things take longer than they're supposed to. There he goes. Woohoo! All right. So with that, now we can see what happened. And we can see Our auto-created stat is still here, but now we have a stat associated with that index we just created. Now we can start looking at some of the differences with the properties. So looking at query again, this is the same query I'm using over and over again. We can now see we have that information. We can see when each one was last updated because they were done differently. The auto-created was created different than the index. Now we can see our auto-created stat is sampled, but a brand new index is full scan. We also notice that they have different numbers of steps. Our stat auto-created stat 198, our index stat is 201. Statistics, histograms are only allowed to have 200 steps. Only 200. Unless you have a null field or null value, and then you have its own step, and so then you allow for 201. So if you're looking at your index and you have 201 steps, it means one of them represents nulls. You have nulls in your values. You don't see that here, but you can easily see it here when it needs to use all 200 steps. So now I'm curious. I want to see what's in those steps. How are they broken out? How different are they at this point? So now I can use the same query, throw my histogram in instead, and look just for those two stats. And I can actually do a side-by-side comparison to see what happens. What does it look like when you sample something versus have a full scan? Well, nulls, the values for equal rows are actually a little different. They're slightly off, pretty close. -1 happens to be in the same bucket. Again, numbers are off. It's what happens when you get samples. And for the most part, things are different, but hey, every now and then you have things that line up. That's kind of cool. But it doesn't stay that way after a certain point. And we can also see that the numbers for even when they do line up, because we're getting estimates, we're actually getting slightly different pieces of information. That's interesting to note. We'll keep that in the back of the mind when we try to pull all of this stuff together. Now let's see what happens when we do updates. For the purposes of our demos today, I'm updating everything to be the same value. If there are different values, that's definitely going to affect distribution. I'm not quite interested in that just yet, but as long as you take a column and update it, it counts towards the modification counter. It says, hey, you updated something. Here you go. It just means you need to look at your stats because you hit certain thresholds. So I'm updating. And here we go. And now we can take a look to see what happens with our stats now. And as we zoom in, we're looking at these bottom two. We can now see both of these have modification counters. And I've added two columns here. These are the calculations to figure out how many rows need to change to trigger an auto update of that statistic. It changed between 2014 and 2016. Pre-2014 and earlier, it was 20% of the rows plus 500. For 2016 and higher, it is the square root of 1,000 times the number of rows. So for 2014, we can see it was over 1 million records have to change in order to trigger an auto stats update. For 2016, it's much lower, it's 230,000. We just updated 561,000. So this, and I'm on SQL Server 2022. So it means next time I do a select statement where this stat is needed, or a query where I need this stat, or especially the updated version of the stat, it will automatically update. Well, I've got two statistics on the same column. So what happens when I do my select? I'm going to make sure I show my execution plan. And we can see everything is here. So what do I want to look at my execution plan? I can actually see what statistics are used to create this. So I'm going to go over to my properties. In this for a moment. And I can find a couple things here. You see this bucket, optimizer stats usage. There were two things that it used. One, it used the statistic for the index on user ID, and it also used the primary key statistic, which makes sense. I'm doing a select all, but it didn't need that stat. One thing I want to point out here, this sample percent, 0.928518. This was a newly created index. My sampling percentage was 100. So when we first created, it was a full scan. When you update the index, the statistic for the index, it's now sampled. So things have changed. It's not what it was before. I did want to note that this is an optimization level full, and I want to one other thing I want to double check and make note of, because we'll take a look at that later, is my query hash and my query plan hash. These look to be the same as they were last time I ran this, so I don't need to update that. We'll come back to this. Oops. All right, now let's check the stat again. We saw something interesting. We saw our sample percent change. We also saw the modification counter went down to 0. So it knows that I made a change. I needed to use that stat again. It needed to be updated. It resends the modification counter back down to 0. But it didn't use the auto-created statistic as part of this. So the modification counter is still sitting where it was before. The only way that's going to change is if I do something that uses that stat. Well, a quick way for us to do that, well, before we do that, let's take a look at their histogram. Are they the same? It now took the same number of sample data, things have changed, and now we can see things like it's lining up. So when it did the sample for the index, it now looks like the sample that we had for the auto-created stat. And all the numbers line up, it's duplicate. So now these happen to be the same. Now I want to change my sample, my auto stat. I want to get rid of that modification. How am I going to do that? Reset the modification counter. The easiest way to do that is drop my index. And then I'm going to rerun that select statement. I'm going to go ahead and look at my execution plan, and I'm going to go over and look at my optimization stat usage. We can see it's using different stats. The first one is now the stat for my primary key. And the second we can see is now the stat that was auto-created. Obviously, the index wasn't there. We can see it sampled, and we can see the modification counter got reset. It's kind of cool. We can see that within our query itself. But there are a couple different changes here. And as I was looking through, I noticed something. My query hash and my query plan hash. Let's see if I can get this to show here. If we looked, our query plan 90990D and then C473EE. If I go back to my properties and I go back to my query hash, my query plan hash, these are the same. It's the same query. I get the same query plan. I get the same plan hash because the query is the same. Everything about it's the same. But we have difference in terms of one is now an optimization level trivial versus the other one, which was full, because there was an index for multiple ways for it to come up with the plan. So even though the statistics that I was using were different, it still managed to come up with the same plan for the same query, which I find fascinating. I'm not going to show you this, but when I was doing my testing for this, I also found that the way it showed up in my query store was also different. Even though the hash was the same, the plan was the same, they still showed up different as different plan IDs and query IDs. Why? Because the statistics used and how it came up with the plan, this optimization level, triggered very different plans. It's very fascinating. I don't have time to go into that now, but definitely play around with it. Check out some of those differences. So now we see how this works with a single column. Let's look to see what it looks like when we deal with multiple columns. So going to my stats overflow database, I'm there. I'm going to create another index on display name. Right now I just have on the primary key. Luckily that one took less time. And now I'm going to look to show stats for both my users and my new index. Couple things I want to make sure I grab for fun reference. The all density for my for the full table. This row is correct. And then I wanted to make sure that grab my display index value alone. And now we can kind of get some information. We see things, again, basic information. I can now select the different pieces of information. One thing I want to point out for our new index, it's an index. When we create an index, it's a single column. But behind the scenes, it's really not just a single column. It is our column with our clustered key added to it. When we look at the statistics for our index, that gets factored in as well. So now we have our all density. We have this column here for display name. Actually, I'm going to go back and I'm going to rerun this just for display name alone to make it a little clearer. We now have two sets of density, one for our display name by itself, and the other for the display name plus our clustered key, which happens to be our primary key because I created the clustered primary key, and that's added. So we now see that information. So we see things like our display name average length is 19. When you include the identity the integer column, we've added 4. 19 plus 4 is 23. And now we have two sets of densities, the uniqueness for just display name across the table, and then the uniqueness with the display name plus ID, which you will see matches what we have for the density that we saw when it was just ID. It's the same thing. Why? ID is unique. So when we add the ID to a key to another index, that also makes it unique. And it just happens to be I know what these columns are, so I can explain that. But it also means that we kind of have a way of figuring out what our uniqueness is based on the different combinations we have. And we'll play with that a little more later. So now we can do things like how many unique display names we have. Let's go back here because these numbers have slightly changed. And then I can take this density, put it here. And then I can figure out the unique display name as a total percent of the columns that are sampled. So I can use our density vector to actually figure out how unique, what am I expecting for uniqueness. Unique display names, 1.8 million out of believe that 2.4 million records. Yeah, I need my commas for these. So what happens if I check from the table directly? Actually, let's run these all together. All right, it's taken just a second. All right, here we go. Unique display name 1884535. Go down to the result 1884535. That's pretty good. We know our total number of users. Percent, if I were to do this from the values from our density vector, 0.76. Doing the same sort of query from our table directly, 0.76. That's pretty good. The one thing I haven't figured out is, again, is the property header is showing a little slightly different value. But for what I would do and for how I would normally check these things, these numbers work pretty closely. It said 0.79 density on my display name. There's a little bit math there that I need to figure out. I'm sure it's in someone else's session, but for our purposes, 0.76 works. That math is going to work for what I would do because honestly, what was I doing before? I was doing something like this. So being able to pull this from the density vector and know that that math is going to match how I used to be doing it, I feel pretty comfortable using that if I were to look at insights overall. Now let's add an index with multiple columns. Let's start building this out a little bit more. So I'm going to use email hash. And then let's show our statistics for that. All right, this is looking a little funky. I have one step, 0 density. I mean, hey, it's a string. I've got strings included. What's going on here? My histogram. Wait, range high key null. Are you saying what I think you're saying? Yep, there's no values. I don't have any values in this table where I have a valid email hash. Well, at least we know what that looks like. Let's move to something else. Let's move to location. So location and display name. That's probably a common combination we'd be looking at for our users. So I'm going to create that index here. Taking a couple seconds. All right, let's look at our stats. All right, now we see something that looks a little bit better. 201 steps. 201 means we've got nulls in our values. Density, uniqueness, we see one for location, we see one for location display name, and then we see one for location display ID. So when we talk about column order and where it may matter, we're starting to see how it works out when we look at our statistics and histograms. Because location, it's the first column in my index, and we see it repeated first here as well. And the next thing that we'll see is our range high key. That's just our location. Display name is part of the index, it's part of the statistic columns, and we get a density, a uniqueness across the entire table, but we don't see that in our histogram. It doesn't come into play because our histogram isn't about everything all together, it's about that first column in the statistics. That's what we're getting the histogram on. So there's some pretty interesting implications on that one. Location, just making sure those are the same. We'll see if we need to reference these a little bit later. So we'll just hold on to that for now. So using our histogram, let's see if all of this stuff lines up with what we have in our properties. Our total range rows should equal the total number of rows that we have, 2465, 713, 2465, 713. So histograms are all lining up. That looks great. Let's look at one histogram in particular, because I was looking through locations, and hey, I found this one for Boston. This is where I am. I'm located in the greater Boston area. Let's use it. Let's see if we can make some of these data, see if our data in the actual table can line up with what we're seeing in the histogram. One thing I'll also note is the range high key before Boston is Bogota, Colombia. So we'll use that in a moment as well. So when we talk about equal row values, I want to just go back to our results here. Our equal row value for Boston, Mass is 2178. So what do we have if we just did location and display name? Where does that 2178 reflect? So when I look at my table, I've got a running total here. So looking at everything all together, we can see that I have 2,090 rows. That's how many unique location and display combinations we have just for Boston, Mass. 2090 for reference. What happens if we just look for Boston? 2178. That's what we have in our histogram. So it really shows that the histogram is really about that first column. It's the distribution of the first column in our statistic or the index, because the index is represented as that stat. Again, this is why we always talk about that first key being important. We really see it because that's the distribution we use. Now let's see that step in general. Can we get those numbers and the statistics to line up from the histogram? So I'm using more window functions here, and I'm going to do a test. I'm going to get between Bogota and Boston. I'm going to get the total count, and then I'm going to do a sum. I'm going to get that running count of the number of rows that are represented, and then I'm going to get the average unique rows as we move through, and I'm going to compare it against that histogram for Boston at the end. I really care about this last row right before Boston because this is the information that we're kind of storing here. Range row 1693, the number of rows in the step between Bogota and Boston that do not equal Boston. Our running total, 1693. Pretty cool. Next, distinct range rows. How many distinct values exist between Bogota and Boston? Well, Boston is our 225th row return from our result set. Move up to 24. That's how many don't equal Boston. Distinct row range, or distinct range rows, excuse me, 224. That checks. The average number of range rows, though the average unique rows from our running total, 755,803, not including Boston, 755,803. Now we start getting into rounding errors, but that's pretty exact. I can trust this histogram because this is a good reflection of the data that I need. Again, it's summarized, it's averaged, but for what I need for insights, I think I can trust these values and I can work with this. Let's do one more thing before we take things out. What do we have if we have a multi-column index and we don't have stats on the other columns, but we're querying off of those? So I'm going to create one more index on the comments table, creation date and post ID. Taking a couple seconds, throw a quick reminder. If you have questions, throw them into the chat, whether it's the Slack or Zoom Q&A if you're on Zoom. I wish I could do Control L for creating that index, but nope, not so much. The awkward index creation time. Because our next query that we're going to use, we can see I'm going to select from not my first column in my index, my second one. So what does that mean for my statistics? My machine's running just a little slower just to make sure that demos in a live stream, just that much more awkward. All right, here we go. I'm just going to get the estimated query. We know if anything's needed, it's going to create that. So let's just go ahead and look at our statistics. And we can see that even though I have an index, even though I have a statistic for that index that should cover post ID, it's not used. It needs additional information, so it auto-created a statistic for post. And so now how is that affected by updates? I'm going to do a quick update, small number of records. And if I look at my stats, we can see that I have a modification just on the statistic for that column. Again, the histogram, it doesn't count because it's on creation date. That's the information. I didn't change that. I just changed my post or updated post. I didn't technically change it. And so now I can look, and we can kind of confirm this. I can look at the execution plan. And I can go over and I can confirm what statistics are being used here. My first stat is my auto-created statistic. And we can see that I have a modification count. It's not high enough to trigger a changes. So at least notes that. It's also interesting this is a lower sampling percent than I've seen elsewhere. My second stat that it uses is the statistic for the index, because we do need that because I am looking at creation date. The data I need is probably all on the stat or on the index. That's where to find the data. The distribution I need is really about post, and that's so it needs both of those pieces of information. All right. So that's what I wanted to show here. So now we have an idea of how things look like from the individual changes. I do have a demo for filtered indexes, but I always get so confused on this because filtered indexes and what I just showed you don't quite work well together. I've got resources on that. You'll have access to this later. It's really a head scratcher, so I'm skipping over that for now because I want to get to what the overall arching of what we're looking at, which is what do things look like within a workload? Now that we understand how everything works individually, I'm looking for insights. Insights are not about those individual queries. That's when you go into performance tuning and how statistics affects your query plans. I'm not really interested in that. I want broader insights. So what I did is I created a second Stack Overflow database, and I'm calling it Mimic Use. And essentially, I used some of the data. I created a workload later that created posts, I created comments, I created views, and then I had something that essentially paged through selecting data. It's not a full usage, but it got enough where we can kind of see what things look like at a snapshot in time. So if I were to run this query, I'm looking at stats columns, I'm looking at the tables, and then I'm looking at my properties. I'm looking for things where modification counter has been changed. So we can kind of see data is changing throughout the day. And I really wanted to focus on some of that information. And we can kind of see the effects that things have as our workloads are running on our statistics, especially if we want to use this for other information later. Things that I can see, I can do my query to say, hey, is anything ready to be updated? Got a couple stats ready to be updated. For post, my accepted answer is ready to be updated, because when I have you have different information based on accepted answer. So when I created a post and it's an accepted answer to another post, I have to go back and do that update. So 2 updates in that case. And we can start saying things like our row numbers across post. Let me highlight all of these. They're now slightly different. Some of these have been updated or showing, different rows within the table. Rows sampled for most of these are the same. And we can start saying things like the rows that I have for accepted answer is different, but we also see it hadn't been updated in 7 minutes because we hadn't hit the point where auto updates needed to be triggered. And so now my data is out of sync for the statistics. We can see comments. I have some auto-created stats that really haven't been used. Look at those, look at those modification counters versus the ones for these other columns or associated with these indexes. This 2 days ago. So we're not making changes that often, but we start seeing that our data is a little out of sync. But we do see how things work, and we can see how things change, and we can see the state of our data throughout the workload. So when we're thinking about how am I grabbing insights, what do I need to do? Where should I be sitting? Where does my data need to sit? So assuming this is my project, what am I going to do? Am I going to want to grab my data while it's in motion? Probably not. What I'm probably going to do is find a time where I can get clean stats. I mean, first of all, I'm probably just going to do something like update my stats, just run exec sp update stats. But is that really going to work for what I want it to do? For example, am I going to get full scans on my indexes again? Well, no, I still have sampled on comments. So 74,000, I'm getting 29,000 here. So now we can start seeing different sample rates that we're getting based on the number of rows that we have. Because previously, we'd had those 5 million records in our table. We got less than 1%. This is, about a third, 33%. So we're getting different sample rates based on what our rows are. Is that going to work for what I'm looking for as I'm really trying to grab some of this information? It may not be. What I may choose to do instead is go through my maintenance. I'm grabbing one of Ola Hallegren's scripts to run index optimize. I'm going to force even low fragmentation to do a rebuild so I can really see if I can get a full scan on some of my data. While I run this, I'm also going to point out that there's also an option to update all your stats as well, because certain index maintenance does not necessarily trigger a stats update. Things like reorg, that may not trigger an update of your statistics. But here, if I just say rebuild, the ones that it can rebuild, I'm going to get 100% full scan on for the stats associated with index. Auto create would still be sampled. And for my purposes, that may be okay, depending on what I want to do. And once I start looking at numbers and really figuring out what the data is telling me. You're going to depend. One thing I would point out that is if you're doing this for a production, base your numbers and what the stats that you're getting, base what you're getting off of production. based on the time that you're getting the information from production. Because what I'm looking at is I'm looking at insights. And regardless of when I'm doing something, I'm going to get a snapshot in time. Maybe there's transactions going on that I'm ignoring as part of my data that I would collect if I were selecting from the tables directly. But production and statistics are going to have a bigger impact on your production. If I'm looking for general insights, I'm looking for high-level information. This is why I think it's okay when some of my data was going through and I was getting off by, 7.79 versus 0.76. I'm okay with that 3% difference because for what I'm looking for, I'm not necessarily going to get that much of a difference. It's not going to be that much of a change. But for here, trying to get this for a demo, of course, everything's taking longer than I'd like. We can kind of get the idea of if I can get it and grab my stats and grab these queries soon after I do index maintenance on my system, I may get a better idea because, again, that data is going to change soon, and I'm really looking for that snapshot in time. So now that my statistics are updated, I can now start doing queries to figure out things like completeness of data. So I have this big fun one right here where I'm going to look at my stats columns, my column information directly. I can look at types, properties, histograms, pull all of this stuff together, and I can start coming out with things, something like a report. So let's get rid of this so I have more screen real estate. So I can do things like I can look at my comment score. First column in there, it's auto-created. I can go over and I can say, hey, how many zeros are in there? 76% of the rows that I have sampled have 0. Does that mean that scores are valid or is 0 used to be a placeholder? Even though it's nullable, is that better? Is that worse? Well, what do we have over here? User IDs for comments. Let's go over here. It allows nulls. I can see the number of nulls that I have, and I can see that percent. Okay, that one may not mean much. But down here we have one. We have stuff that may be more meaningful. For example, my last editor user ID on my post table. I've not been populating that as part of my workload. So I can go here and I can say the number of nulls equals the number of rows because I'm not populating it, and it's a 100%. So now I can start answering things about completeness. How many nulls are there? How many nulls are not there? Things about how many zeros, are those accurate? I also have things like percent of empty strings. If I have empty string as a high key value, can I look there to see if I have any empty strings? This one over here, I believe, is our display name. Yikes. Zoomed is not my friend today. Display name, I scroll over. Hey, look, 14 empty strings in our display name. So now I have a little more information about the distribution of data. Does that mean my data is complete or not? So now I can do things like, hey, I'm seeing values. I can look at dates. I need to know the range of dates in a really long, 52 million log table. I can do things like look at my statistics, say, hey, what's my minimum high range key for this date field? Because I'm combining it with columns. I'm getting my date type. Minimum high range that I have is, 2012. Nothing below it, so I can say this with certainty. Yep, these are the lowest dates that I have in these columns. And then I've got my max high range key, which is my max value. Hey, I now have a range for my entire table without having to select min max from my table. And I'm not doing it per individual table. I'm doing it with one query rather than the total number of queries that I'm executing this for. That's kind of fun. Ooh, uniqueness. Density vector. Well, I'm really only able to find density vector through dbcc show statistics. But there is a way I can get just the density vector so I can get those unique combinations. So what if I created a cursor for everything, ran that through the density vector, threw it in a temp table, and ran a query? And so in less than a second, I can now look at things and say, hey, what are the approximate number of unique rows? Because it's sampled, if density vector, if it's sampled, it's based on that. The approximate number of unique rows based on the sample, percent uniqueness. I can do things, look at average length, how long are those keys together, as well as the number of steps. But hey, I can get the average length. Could I use average length to figure out if a table is properly sized? For example, looking at display name by itself, average length is 19. Using the max length column from syscolumns, that's 80. That's quite a disparity. Is display name too long? Is 80 too long for a display name? We have types here. A type is 7.5 and the max column length is 50. Is 50 too high? So now I can start going down that rabbit hole and say, hey, are my columns sized properly? I've got distinct values for the columns. I can start figuring that out by looking at everything all together. How many distinct values do I have? So now I get a distribution of, are these values unique? I can start doing those sort of calculations just by going the histogram. But it's a single query across my entire database. You've got 500 tables. Do you want to do this query 500 times on each one of those objects to get this information? No, I don't. I'm lazy. But here's the other thing. This one's a fun one. My colleague introduced me to a concept called key attributes. It is kind of a data governance thing. When we database people think of attributes and key attributes, we think primary keys, we think alternate keys or unique keys. From a business continuity, or not continuity, from a business perspective, a key column may be a column that's important to the business. And it's not necessarily having to be unique or something that's part of an index, but it's something that's really important for us to use. So what if I took this query that Jonathan Cahias did, searching through SQL query plan cache. He was using it for missing indexes. I'm going to use it on our statistics. And I'm going to pull out our database schema table statistic names. This is from that optimizer stats usage that I showed you in the query plan. I'm going to focus on my tables that I care about. And I'm going to use query store. I mean, if you're not using query store for who knows what reason, you could use plan cache DMVs. But I can go through, I can get the XML of my query plan. I can start pulling stuff together. And then I can start doing things like saying, hey, how many queries is this stat used in? How many plan IDs is that stat used in? How many total executions are involved? Executions of these query plans involve this particular statistic. And I can summarize things and I can get an idea of maybe not which statistic by itself, but at least which tables are really used in statistics throughout my workload by how we're querying them, what statistics are important, and figuring out that sort of information. This one takes a bit. I'm going to blame going through XML and the fact that my machine is being slow with demos today. But again, there are ways we can find information that we didn't expect and different insights. Because we want everything properly indexed, but how often are we using those tables or the stats for those indexes being used? Give it another couple seconds. Because the great thing with all of these things that I'm showing you, these are all done through queries. You may not want to do this on your production system. You may want to do this elsewhere. So you can actually take these select statements. Maybe you want to select everything from query store, dump it into a new database and deal with it there. You could probably do things with stats as well, but there's another way we can take stats. While this is running, I'm going to be very dangerous and try to do something else, and then we'll come back and see if the results are here. We can take stats and apply them to a different database. So I'm going to go to my databases. Let me zoom in. I'm going to go to my mimic use, where we have all these wonderful statistics. I'm going to go to tasks, and I'm going to go to generate scripts. Let me pull this over. And I'm going to go to next for the wizard as I pull out here. I'm going to script my entire database just for the demo purposes. It's pretty small. Next, I'm going to go to my advanced options. And when I scroll down, you have this option here, script statistics. You got a couple options. You can just say script statistics themselves, or you can grab the histograms as well. And I'm going to do this, and I'm going to open in a new query window. Next. And so now it's going to go through the database. It's going to grab all the statistics, going to create my indexes, script everything out. Go out here. I'm going to click Finish. And I'm going to take the script and I'm going to rename this. Oops. Mimic use, I'm going to do new stats, going to take this everywhere. A couple things I'm going to do is I'm going to double check different default settings. For example, auto stats, update stats, I'm turning off. One of the things when you're doing something like this, you want to make sure you set auto update stats off. I think that is the only one I have here right now. All right, and I'm going to run this. But before I run, I want to show what we have down here. Here are the statistics. So I'm creating all the objects, and then it's going through creating things, and then it's updating them with my histogram. So when I run this, whoops. And while that's running, my query has finished. And now we can look back. Sorry to jump back and forth between these two, but I wanted to show you we can now look and we can look at our statistics and we can see the number of queries that are involved, the number of plans are involved, and our total execution count. So we can sit there and say, hey, these statistics are used pretty often. Funny, it's not used as often as our primary key constraint index or statistic, but we can now see what statistics are involved as we come up with different query plans. And so you can say things like, well, post is at the top, our post table. So this one's probably a very important table to have. It doesn't matter how many columns are in the rows are in the table or anything else. It's just we now have a different type of insight, so we can try to figure out which of the columns on our post tables are really the important ones in our entire workload and in our application from a greater sense. But this one was kind of fun because, you know, going through our query plans and associating them with our stats that way. But again, we may not want to use this in our production database. We're going to pull things over. So we now have histograms here in this brand new database. And if I refresh, we can now see I have a new stats database here. I'm going to look at tables, and I'm actually going to hit F7 for our Object Explorer. This is a brand new database. And hey, I've got row counts. Y'all saw me create this database from scratch. It did not exist. There should not be row counts. But because I applied the statistics and histograms, I can do more fun things like, oh, let's take one of these queries here, like this last one. And actually, I'm just going to change my database, run it again. Nothing in the database, but I can look at the statistics. I can query these. And so now I can get all of my insights that I want without having to touch production. I can run this secondarily. If I wanted to, I could take this data, then insert it into a new database on the separate server, start keeping track of changes over time. This is not something I'm looking at every day, every hour or so, but I'm looking at it often enough where I can probably put all of this stuff together, start catching trends over time, and building up information that way. So that's pretty exciting stuff. I'm pretty psyched about figuring all of those sort of things out. So now it comes back, we've understand stats, we've done some queries, we've connected it with metadata looking at overall workloads. So is this a solution to my work project? Could I have used statistics to get the same information? I think so. I can definitely answer questions directly about uniqueness. Density vector right there, histogram, equal rows, it works. And I've definitely been able to join it to other metadata and query plans so I can start getting some of those larger data profiling questions answered. There is a caveat. It's not perfect. Completeness has to be implied in some cases. There's definitely additional information, things that I need to look at. Doesn't fully answer data quality issues. And statistics don't cover everything in advance, and so there is extra work that's needed. I would say if you want to go on or down this route, see if it works for you, what it tells you. Again, don't do it in production. Copy data to a different database, query from there. Turn off auto updates of stats if you're going to copy histograms directly. It's actually a fun way you can test performance without actually having to get production level data. But you also may want to think about getting some of this data after your maintenance plans so you can try to get it as close to clean as possible. Hopefully you'll get those index full scans again. Your statistics are updated. It's a cleaner snapshot in time before everyone makes all the changes they want. Because it's important to remember this is just snapshot information, right? We're not getting those real-time updates. We're not getting those real-time changes. And it's also aggregated information. It's just a snapshot. When you're doing data profile, you're probably just getting that snapshot information regardless of how you get it, but you want the different asterisks to say, explain where you got it from, when you got it from, so you can explain where the data comes from, why the numbers look the way they are, and what you want to look into next. If you're doing changes over time, obviously you can do that, but you'll want to make changes on how you're capturing data, where you're storing. But I think it's probably possible. With that, I want to say I used a ton of resources putting this together. Microsoft Learn, I spent way too much time on those, making sure I understood the distinction between them. So here are a couple ones that pages I spent a lot of time on. Other ones where I got the definitions for data quality, profiling. Aaron Stellato's session on statistics from a couple years ago from this conference. Andy's session, which was based on Aaron's or used a lot of her information. They're definitely different, but they definitely work nicely together. I mentioned Kendra's blog post about statistics versus designing indexes and such. Brent Ozar's how you get the Stack Overflow database. I didn't go into filtered indexes, but yes, it took me at least 3 blog posts to go through and say, oh, filtered indexes don't really follow the right pattern we want for this. So I'm leaving those there for later. So with that, I can breathe and say, do you all have any questions?
Fantastic job, Deborah. You've definitely melted the hell out of some brains today. But yes, we do have some questions and some comments. So I'm going to try and go in chronological order in the couple of minutes that we happen to have left. First of all, Theo in Slack was mentioning that he really loves that compare stats query because it's now going to allow him to finally end a decades-old argument that Theo has been having with another DBA about how stats change with the sample percentage and the usefulness of 100% sample rate in a table that is billions of rows. So Theo says, thank you specifically for that particular demo.
Great. And remember, though, it's sampled. Like, it's probably okay that it's sampled. So don't get hung up too much on that, on the sample rates, unless it's affecting performance. But it's great to kind of understand how it works at least.
Yep. And then going along with that, Theo also has 2 questions for now. So if you have a wide table that has billions of rows with an index on some integer column that has hundreds of thousands of different distinct values, considering that a histogram can only have 200 buckets, what might be a good rule of thumb for a sample percentage for that kind of table and data distribution?
That gets into performance. Because again, when you're talking about distribution, SQL Server is going to figure out the distribution. I try not to outsmart SQL Server because I think it's going to win every single time. So when we think about the way it breaks out the buckets, it's just figuring out how to display, it's got 200 slots. How is it going to distribute all of that data? When it gets terms of how it's going to use in terms of performance, that's going to be a separate one. In terms of finding out what the uniqueness is, if you need to set a sample percentage for that, you're going to want to play around with performance. I think that's what you're asking. Does that sound right?
I believe so, yes.
Okay.
So next question. If you have a multi-column statistic, could we use vector density to weed out indexes that lose its usefulness after column 3, 4, or 5 because the number of rows it would select or exclude after row 3 or 5 no longer increases, and thus make the index smaller and faster?
Again, this gets into kind of how it's used. You can use density vector to say how much uniqueness you have in those row combinations. That's what you're asking. Feels like it's more about the index usefulness in terms of is that index being used in queries at all, which is a different question. Density vector is going to say, based on these different combinations, how unique are all of those combinations across the number of rows sampled. So at a certain point, it's not necessarily uniqueness. Remember that we're talking about the distribution of data, not how it's being used. So make sure your indexes are being used, and you're going to look in a different place for the query plans, whether your indexes are being used or not. There are some great, Glenn Berry's got some great indexes or great queries that'll help you answer some of those questions. But density vector is going, hey, is this a unique key combination that I should have a unique constraint on? It could probably answer that sort of question for you, not whether at a certain point are all of those do all of those columns need to be on that index. So this is really where it's understanding that fine line between what an index is and what a statistic for the index says, and how those are being used by the optimizer.
Cool. So with that, we are a couple minutes over. So we're cutting into the little break time right now. So I think we should wrap things up at this point. Dan and Erland, we'll make sure that Deborah addresses your questions in the Slack channel. Make sure that you jump over to the Slack as well. So, but otherwise, fantastic job. You also got another session was amazing and mind-boggling stuff comment. And yeah. Good stuff.
Great. Yeah. If you have questions, I'll look at the Slack channel, try to answer those. If not, you have my contact information here, or if they're in QA and we didn't get to those, we'll take those and try to answer those. Thank you so much for having me, and thank you for sitting and listening through this. And you got one more great session coming up. So I'm going to go ahead and stop my share.
Definitely solid stuff there, Deborah. Andy actually gave us an idea for a work project that we're going to go do now. We were chatting in the background, some stuff to use some of those techniques. So thank you for that.
Oh, you're very welcome. And I'll try to get these.
Anthony was very happy that you used the term snapshots towards the end as well.
Oh,
different kind of snapshot, though.
Different snapshot, but
snapshot nonetheless.
Multiple types of snapshots exist.
It may or may not be a very overloaded term in the SQL Server world.
Yes, I would agree with that.
Deborah, I just sent you the outstanding questions in our personal chat, by the way.
Okay.
Just fantastic stuff. And as Deborah mentioned, we are coming up to the last session of the day. Unfortunately, Argenis had to cancel, so Amy's session will be the last one, but we will be in contact in the next week or so with a new date for our Genesis Black Box LLM internal session. So watch out for that. Again, here's the slide with all of our resources, our GitHub, our YouTube. Am I right in thinking that the full event goes pretty much online immediately, chaps, because we're streaming to YouTube?
That'll be available immediately, and then I'll check individual sessions and publish that to the YouTube channel, hopefully by this weekend, if I actually do work on the weekends. But here we are.
Fantastic stuff. And so, oh nope, again, please do leave feedback for Deborah, for us. Tell us what you liked, what you didn't like. We always want to make things better. Speakers love feedback as well, knowing that they can build on their sessions and constantly improve. So I'll leave that up for a little bit there. As we're coming up to, we got about 6 minutes until the next session. So, and again, that will be our last one today, unfortunately, but we'll be in contact. How are we all doing? How's everyone's heads? Mind melty enough? Ha!
Hey, Amy, you there? I see you're on. You want to kick in your audio and video?
Yeah, I've been watching from my other email just because I didn't want to interrupt or join or do something on accident. So I've been watching. It's been amazing content. I loved your session, Deborah.
Oh, thank you. And I've gotten previews of yours, and it's going to be awesome.
Thanks. I'm really excited.
And I'm sticking around because I'm also going to be moderating this session. So you get another double dose of me. Not that I'm doing much.
Yeah, this day has just been flying by.
Yeah, absolutely. I mean, it's 25 to 7 p.m. where I am, so it's absolutely just gone like that. Always
Andrew,
does.
Rob,
Always.
have you opened up beers yet?
No, not yet. Rob? Not yet. It's getting close to the witching hour, though. Okay. We're about 4 minutes. I will stop sharing my screen. Amy, if you want to grab the screen.
Yeah, sure. Can you guys see that?
Yes, we can.
Okay, let me get my slide deck pulled up. Just so it's there.
Fantastic. So we've got about 3 minutes before we'll kick off. We'll kick off at 20 to the hour. So, and I'll introduce you for the recording when we split these sessions up. And then it's all yours to take it away.
Perfect. Where are you based out of? Where are you from?
I'm based in Dublin, Ireland.
Oh my gosh, I went
Chicago.
there last year. Oh my gosh, you were so lucky. I want to live there.
It's rained every single day this summer. Every single day.
Except when Deborah and I were there for Data Kaylee. It was gorgeous weather then.
You had about 3 days of it, and it did rain at one point.
That's why it's so
Yeah.
green though. Scotland and Ireland, they probably the entire time that I was there, it rained. But it was great. It's better than snow.
Yeah, so the whole country here will grind to the halt the second one snowflake hits the ground.
Yeah, I'm from Utah, so we get a lot of snow.
That's not been too bad. I mean, it comes in patches. So I'm heading over to County Mayo this weekend. It's the only place in the world I've ever seen rain come up at you. So I had a friend who moved out there and when he said he was moving to the west coast of Ireland, he wasn't kidding, because the next stop literally is America. It's, if you Google Belmullet in County Mayo in Ireland, you'll see what I'm talking about. But it's right on the west coast, as far out as you can go.
Well, when we were down there, it was funny because we went to the Cliffs of Moher. Actually, I had to go alone because my mom ended up getting COVID at the same time. And anyway, when I went to the Cliffs of Moher, I went to go take a picture, and I took a picture, and then all of a sudden the clouds came in and you couldn't take any more pictures. It was for a split second, and all of the tourists and everything were just so disappointed, but I got really lucky.
I've been to the Cliffs of Moher once. I'm not very good with heights. I stayed as far back from that edge as I possibly could, because it's a long, long, long way down. Yeah, so no, it's beautiful, but terrifying at the same time.
Oh yeah.
Okay, how long have we got? We've got less than a minute. Okay, I think, should we kick off? Yes,
Sure.
let's kick off. All right. Hello, everyone, and welcome to our last session of today. We have Amy Abel here with her session on SQL Server Split Brain, navigating availability challenges and preventative strategies. Amy, over to you.
Awesome. Andy, do you want to start?
Sure. Before we begin, I will also be moderating this session as well. Amy has asked that all questions be held until the end of this presentation. I will be monitoring both the Slack channel and the webinar Q&A. So if you happen to have any questions, please send them on over, and we'll make sure that Amy gets to them afterwards. Otherwise, Amy, the floor is yours.
Okay, awesome. Thank you. And thank you for having me.
Good afternoon, everyone, and thank you for being here. Today, we're going to discuss the high availability challenges and preventative strategies. Mainly, we're going to talk about split brain. My name is Amy Abel. I've been with Advanced MD for the past 5 years. I'm a senior DBA. I'm married. I have 2 dogs. I enjoy jeeping, traveling, speaking, mentoring, and I have a ton of passion around SQL Server. It's funny because we were just talking about Ireland, and that's one of the screenshots that I have in there is when I went to Ireland last year. But yeah, one of my favorite things is to solve complex problems, which is why I'm here today to talk about preventing split brain scenarios in SQL Server. And then I also put on there my blog post site, AAA-DBA.com. I'm always open to new blog ideas. Like if you guys want me to blog about something, if you're having an issue with something, definitely let me know. And then I do have my LinkedIn in there if you want to add me as a contact. Before diving in, I want to thank 8KB and everyone involved for organizing this event, including Andrew, Anthony, Mark, Marsha, and any other presenter or helper that was attending today, and especially Andy Yoon, who's going to be moderating for me. Okay, so I'm having a nice calm day, focusing on possibly rewriting a horrible merge statement, when all of a sudden everything goes sideways. Boom! Now, if you're not awake, you are now, right? So all of a sudden, errors and clusters are going sideways. The production servers are randomly failing over. They're leaving some bizarre state where the clients can't even access their data. Just like that, the entire environment is in chaos. So, you know, by that time, the other DBAs are on board. We're trying to ping the listeners, but half of the clusters are getting nothing. And my team's notifications were blowing up. Customers are frantically calling in. The queue is building. My boss is demanding answers. And then I am completely in the dark because I have no sense of what is going on around me. And this is the reason why I am presenting today, because I'm sharing some firsthand experience on split brain, and I want to educate others to help prevent you from having this nightmare. Because if you've ever heard the saying, prevention is better than a cure, that's absolutely true. Now, during this session, I have 3 goals, and I hope that you can help me achieve them. The first one is I want you to understand what split brain is. And this is very important to me because not very many people know what it is. I was actually talking to someone yesterday in the lunchroom, and I was telling him, yeah, I'll be presenting on split brain tomorrow. And he's like, what is that? That's a little bit concerning in our, you know, SQL Server area. So the second one is I want you to know what causes the split brain, because that's also important, especially when you're trying to prevent it. And then the third one is, how are you going to prevent it? I know that this can seem like a very complex topic, but I'm going to make it easy today. So let's start with some concepts and some terminology to ensure that we're all on the same page. Now, I know that some of you might be experts in SQL Server. Trust me, I know you're probably better than me at SQL Server at this point. But I think that this might also be helpful just to go over the basics for other people in this meeting. So in SQL Server, a node is a single server within a cluster. Each node has its own hardware, its own software. It can run SQL Server independently. A cluster is a group of connected servers called nodes, right? So if you hear me use the word node or server interchangeably, it's because I'm talking about a server / node within a cluster. Now, they work together to keep the database running smoothly, and it's supposed to make it more reliable. If one server or node fails, then another one can quickly take over, and that minimizes the downtime. Typically, a cluster has a primary and then one or more secondary servers. You can have up to 8 secondary servers in SQL Server, and this assures that your data is, now, I'm not going to say always available, because in my career, it's not always been available, but it does reduce your downtime if the primary fails. So remember, in a cluster, you generally have a primary that's the one that's in charge, right? And we're going to be very, I would say, simple in this presentation, because there are going to be other ways to cluster, but we just want to get the 3 goals accomplished here. So a quorum is like a voting system that helps decide which servers should be in charge in a cluster. If there is an issue, the quorum assigns a vote as the primary, and that prevents conflicts. And you'll see why that's important. Now, this is the coolest thing ever, and I had to include it. But nodes send a regular heartbeat, and it comes through as a signal. They show that they're running. So if a signal is missed, a node is assumed that it's failing, and then it checks in with the quorum resource to decide which one should stay active. This constant heartbeat monitoring ensures that the cluster remains stable and the nodes don't act independently. Now that we understand what a cluster and quorum are, let's define split brain. Now, split brain happens when 2 or more groups of nodes, they lose connection at once. And then once the connection is restored, both of the servers think that they are the primary, and that causes conflict. Now, you can see that this could be a little bit confusing, right? Especially for the cluster. Now, I want to point something out. We just accomplished my first goal, and that's that you understand what split brain is. So you can go home and tell your friends that if you didn't understand what split brain was, you actually know what it is now. And maybe you will look really cool around your employee, or, you know, your friends or the people that you work with. So that's a big milestone. You learned something new today, hopefully, and maybe you'll learn some more. So let's take a look at how split brain scenarios can happen. Understanding these causes, it's very critical for preventing them and keeping your cluster stable. Here's some common factors that can lead to split brain scenarios. The first one is network failures. That can cause issues between the nodes, and it can lead them to acting independently. Incorrect settings, that can result in nodes not agreeing on the cluster state. Issues with storage hardware, that can isolate parts of the cluster. And you have bugs, and that can cause glitches, and that can disrupt the communication and coordination between the nodes. And then our favorite, power outages. They can affect the cluster, and that can cause the nodes to become isolated as well. Now, I know some of you are saying, well, I'm in AWS. We're not going to have any power outages. Yeah, sure. AWS power outages can still occur. I hate to tell you that. Other split brain causes. Now, if the quorum is not properly configured, or if the nodes lose communication with each other, the cluster might struggle to determine which one's the primary node. If you have complex failover logic, that can cause unpredictable failovers, and that can lead to conflicting decisions among the nodes. Incorrect manual interventions. Now, a lot of people are like, well, we don't have to do anything manual. Well, that actually depends, because sometimes you're going to have a node that needs to be restarted because it's in a funky state. Network reconfigurations that happen within the team, like maybe you're doing something in AWS or changing VPCs or whatever it is that can cause network blips. You can have planned maintenance that happen that can cause split brain. Maybe you're doing OS patching and maybe you need to restart SQL. All of these things are things to consider. Resource contentions, issues like limited the memory, CPU usage if it's high, you know, and the node's not it can't communicate, it's too overloaded, that can disrupt the communication within the cluster as well. And that can lead to split brain. To understand what causes split brain, I think we need to consider any situation that can potentially bring a server down. Now, you're probably wondering why I'm so excited right now, and that's because we're already moving along. We've accomplished my second goal, and that's that we understand what causes split brain. So remember, any situation that could potentially bring a server down, even multiple server down, because remember, definition of split brain. And then a split brain scenario in SQL Server can significantly impact data integrity, availability, overall system functionality. And we're going to look at some of those side effects. I'm not going to try to scare you, but it is pretty scary. When you're in the weeds anyway. I mean, I never want to deal with it again. Okay, so in a split brain scenario, nodes working separately can make conflicting changes to the same data. When they try to sync, when they try to sync back up, that leads to data corruption because of the inconsistencies, making it difficult to determine what the correct version is. Recovering from split brain is very difficult. It's time consuming. It's often challenging. It also increases the DBA workload. Most of the time, if not all of the time, I'm going to tell you that manual intervention is normally needed, and it comes from a DBA. Transactions that occur before split might not be properly recorded. That leads to lost transactions and data gaps. Now, let's talk about some key preventative strategies to maintain a stable cluster environment and avoid issues like split brain, because you know, the most important part about this presentation, like I said, is that you understand what it is and you understand how to prevent it. There's a quorum configuration, and this is critical for a clustered environment because it ensures that most of the servers agree on the cluster state before making any changes and that its operations continue. This agreement prevents situations where a server might act independently, which can lead to split brain issues. And then SQL Server supports different models to help manage this process. We're going to talk about those models. And I added some slides in here so that we can look at what those examples might be. The first example is node majority vote. Now, node majority vote is kind of less common, but I don't want to say that because everybody's environment is going to be different in the way that they do things. So I can't say one is less common than the other without knowing how everything's built. But the great thing about it is that it's just very straightforward. So it's based on the number of nodes, and as you can see in the screenshot here, nodes, remember servers, we have 4 here. So we have 4 votes. Each server has a vote. And this requires an odd number of nodes to avoid ties. So for instance, if you have 4 servers or two servers in an environment, node majority might not be the best if you don't have dynamic on, but we're going to talk about dynamic. So I don't want to confuse you. I should have actually just put 3 servers on the slide because generally that's probably what you would want is 3 or more on a node majority. So the advantages are that it's high fault tolerance and it's consistency. It's simple to understand and implement. There's no need for additional resources like a disk or a file share witness. But the disadvantages are that it requires a majority of nodes to be operational, which can be challenging in larger clusters. Network partitions can result in loss of quorum if majority is not maintained. So one of the things, the reason why I say majority is because you need to have majority of your cluster up and running, your votes up and running in order for you to have your cluster healthy. And I'm going to show you examples once we get through each node majority of what that would look like. The disadvantages are that this requires, this can require a lot more cost. So for instance, if you're just building a server in AWS to have it used as a tiebreaker or an extra boat, and you're not using it, it's probably going to be expensive, right? The other thing is that if the network has issues and most of the majority is lost and it cannot be maintained, then that's a problem. So there's just a few advantages and disadvantages for each one, and it's just going to depend on what your environment has and what you decide is best. The next one is the example of a node and disk majority. And this model combines the votes of the nodes with a quorum disk. And the disk helps provide additional stability, acting as a tiebreaker if the nodes cannot agree. Now, the requirement for this type of setup is that you need to have a shared disk that all the nodes can have access to, which also have a vote. And then the LUN should be about 512 megabytes and excluded from the backups or antivirus scanning. I wouldn't do I would keep that as a best practice based on the documentation that Microsoft provides. Now, the advantages are that it increases the resilience of node failures. The disk witness can help maintain quorum during a split brain scenario because you have that tiebreaker vote. And then it's suitable for clusters within an even number of nodes. Because we talked about it a little bit in the very beginning of the slides, is that we should probably have, you know, a node majority, an odd number of votes. And we'll talk about that a little bit more too, as I give you some more examples. Disadvantage to this whole example is that it requires a reliable shared solution. If it's not reliable, do not use it. If it is something that you're going to have to do anti-scans on or antivirus scans or anything like that, you probably shouldn't use it. But like I said, it's a learning process, right? And then also the other thing is the disk witness can be a single point of failure if it's not properly managed. So that's some reasons why it would be good and it may be bad. There is a newer option. If you are in the cloud, we're not going to cover too much on this one because the fact that it is more Azure based. But I kind of just wanted to give you an overall description for people that are in the cloud and they are using Azure, that there is a cloud-based witness available. And this one uses a cloud service as a witness to form a quorum. And the cloud witness is lightweight. It's hosted in the cloud, and it just requires a few things. One, that you typically have, you know, it can work with any amount of nodes, but you probably want to have 3 or more. It also has that you also are most likely going to be in Azure, because if you look up documentation, it's the Azure Cloud Witness. And then the other thing is that you need a reliable internet connection, and it's all going to depend on how you're set up. Personally, like, I don't know if I would, I was excited about the Cloud Witness, but after reading lots of blogs and people that were using the Cloud Witness, they seem to have problems. And the reasons why is because they did not have the reliable internet connectivity to the cloud service. And they also had latency issues. So, like I said, it's something that you're just going to have to figure out, learn, and see what works best for your environment. The advantages are that you don't need an additional on-prem hardware or storage solution. It simplifies the setup, and it could reduce the cost. Now, everything is going to come at a cost, so I can't say it's going to be cheap. But if you're using a tiebreaker, you know, an instance as a tiebreaker, this probably is going to be a cheaper option for you. And then it's also suitable for clusters even with an even number of nodes. So the disadvantages, you need to have reliable internet connectivity, access to the cloud service. You know, you're going to have possible latency issues depending on the location of the cloud service that's relative to the cluster. You're going to have ongoing cloud costs, and it, you know, it might be minimal, but it's just something to. The next example would be node and file share witness majority. And this is a combination of node votes and a file share. So the file share acts as a witness, and this setup also helps dissolve, you know, any disagreements in the cluster that if they can't make any decisions because of a node is down. So it plays a part in a vote. You should make sure that the file share is at least 5 megabytes, that has access to the cluster and all the nodes. It's joined to the domain, and your version will depend on what's available. So for instance, if you're in SQL 2008, well, that's going to be a little tricky for you. So I would say look at your version. And see, you know, as far as all of these options that I'm kind of throwing out there is what's going to be available for the SQL version that you're on. If you're on SQL Server 2016, you're probably going to have, if not most or all of these options, because I'm thinking back and I think that's, I mean, even 2012, you're probably going to have a lot more options, but not 2008. I hope you guys aren't on 2008 anyway. But anyway, this must be dedicated to a single cluster, and it's not used to store your user or application data. You can have one file share at a time on your cluster. The reason why I want to bring this up is because, you know, if you're wanting extra votes and you're trying to play the system, you're probably thinking, well, why can't I just have 2 file shares? And then, you know, I can have the less nodes to vote, right? No, when you go to add a file share, it will take the other file share offline. You ain't gonna trick the system here. So I just thought I'd throw that out there. Now advantages are that similar to node and disk majority is that using a file share can be more flexible. It can be easier to set up. You don't need to have a huge infrastructure. The only thing that you need is like we talked about, the prerequisites of a file share. So no need for shared storage infrastructure is basically what I'm trying to say. It's suitable for clusters that, especially if you're using an even number of nodes, like this is going to be beneficial for you, and you're going to understand why here in a minute. Now the disadvantages are that it does require a reliable network share, which can be a single point of failure if it's not. You do need to maintain majority still, because when I'm saying majority, if majority of your environment goes down, your cluster is not going to be up and running anyway. So you need to consider that. Network latency and connectivity issues can also impact the quorum here. Now, a reason why you would want to use the file share is if you're not able to use the cloud witness because your cluster nodes don't have reliable internet connection, and your disk witness can't be used because there aren't any shared drives to use the disk witness. So this is the reason why you would want to fall back on the file witness vote. This one right here, this one's deprecated. It's something that I would say that if you're using this, I would definitely look at your environment and look at other options. because this is heavily outdated. This is no majority, it's disk only. This is the traditional 2003 quorum disk model. This is an older model that relies on the quorum disk for making the decision. And it's not recommended anymore because of the other models that are offered. It just requires that you have a shared disk that have access to all the nodes. The advantages are it's simple to configure, it's easy to set up and manage. There's no need for a majority of nodes to be operational, obviously, because you're relying on the disk. It's suitable for small clusters or, you know, highly volatile environments. But the disadvantages are that you're going to have a lower fault tolerance as because the entire cluster relies on that single point of failure, the disk. So it's not going to be resilient, and you're prone to having issues and failures. So this one, I'm not going to really talk too much more about, just because of the fact that I would stay away from that. Okay, dynamic quorum. Now, this is an awesome concept. I should say it can be awesome. Dynamic quorum allows the cluster to dynamically assign the votes. I believe this came in the version, so this feature was added in 2012 R2, and there was a reason why. And it was because of the fact that they needed some way to make sure that there was always going to be an odd number of votes. And so it's kind of cool depending on how you use it. This feature ensures that the cluster continues operating with if there's just a remaining node, and that's the concept that you might hear of last man standing. So for example, if you have a 4-node cluster without a quorum witness, the quorum would require 3 votes. Remember, because we have to have majority. Without 2 nodes, the cluster would just go offline, especially if you just have 2 nodes and one of the cluster goes offline. Like, what's going to happen there, right? This feature is on by default. You can turn it off. That's not recommended. I think it's a cool feature in SQL Server. Some people might agree and disagree with me, though. So node voting, we're going to summarize node voting just so that you understand this part of it, because it can get kind of confusing, and I'm hoping that my next slides really simplify what I'm trying to present, because this part is very important. The summary is that node majority is best for high node availability, right? It's simple, but it requires majority of nodes. You want to have at least 3. Node and disk majority. Now they add resilience with a disk witness. It's suitable for potential node failures, but it requires shared storage. Node and file share majority. Now it's flexible. With a file share witness, it avoids shared storage, but depends on the network reliability. So if your network's not reliable, that might be a problem. And then no majority. This is deprecated. It's disk only. It's simple, and it might be suitable for small clusters, but let's face it, there's other options available that might work better for you anyway. So in scenarios where there is an even number of nodes, just consider configuring an extra node or disk as a witness to provide an odd number of votes, and that's going to help you prevent split brain. So this is going to be quiz time. Now this is without dynamic on, because remember, you can disable the dynamic feature, and the dynamic feature is more of a balancing act. You're going to understand a little bit more when I explain how it works. You're going to be like, ah, yeah. So without dynamic on, remember the nodes that get readjusted based on the dynamic. This is off. Okay, question. You have 3 nodes and 1 goes down. How many votes do you have? 2. You have 2 votes. Now let's say that you have another option where you have 2 servers and one goes down. What happens? Your cluster's down. You don't have majority anymore. You had 2 servers, and at that point your cluster's probably going to have some problems. Now, the dynamic thing is kind of cool in my opinion, and this is why. Let's say that you have with dynamic on. Okay, we have 1, 2, 3, 4 servers, and then we have a file share. That's a total of 5. How many votes do you think it's going to give you with dynamic on? This is a trick question. 3 votes. Now, some would say, wait a minute. No, there's 4 votes. 1 went away. Why? How did you get 3? Well, with dynamic on, it makes sure that it has an odd number of votes. So for instance, it will say, okay, we want to keep odd, so we only have 3 votes. It may not count one of the nodes automatically. It just readjusts. And then it just does that. And then so when you take servers online and offline or whatever, it just readjusts. It's really cool. With dynamic on, so we have 3 nodes and then a file witness. I should say, yep, file share witness. How many votes do you think are here? 3. If you said 3, you're right. It's because of the fact that at first it probably said that there were, 3 nodes and 3 votes available. Once one of the nodes went offline, it counted the witness as 1 vote because it's dynamic. It switches. Same thing. You have 2 that go down. It's going to have how many? 3 votes. Now, this is probably one of the most important things that I've learned in this entire process. Always make sure that you have an odd number of votes. Everybody gets a vote here. We're giving them away like Oprah. The other setting that I think that you should probably focus on, and this one bit me a little bit, and that's why I'm bringing it up, because a lot of people don't look at their cluster configuration settings. And there's a setting within when you go to roles and you go within your owner settings, you can check to see what nodes are owners. The reason why they do preferred owner settings is it lets you choose which servers should run specific resources in the cluster. And that ensures that the right servers handle the tasks, especially during the issues like network problems. It's important to set this up properly, especially if you are in a multi-region setup where one region may not be active. I am probably guessing maybe 50% of the people watching this are probably more multi-region these days, just because I know that a lot of people are working with disaster recovery options and they need to have those available. Essentially, you're basically just telling the server, you're telling the system who you want in charge in case something goes wrong. I would definitely look at your automatic failover thresholds and your automatic failover settings. This is another great reason to pack on the last example that I gave, and that it's this. If you have a region that is not being used and you have it set to having automatic failovers and it should not fail over to that region, that's going to cause problems, right? So I would look at that. Like if you're having a disaster recovery setup, and let's say that, for example, maybe you're in AWS and you have some in maybe the West or the East or vice versa, Oregon, Ohio, however you want to do it, and you never use that other option unless you really have to, you should be changing your automatic failover options to manual, to not go to that one if it's just being set up and it's not being used. Now, I know everybody's going to have a different opinion on that, but that's just something that I learned. And then the other thing is like, let's say that you're doing OS patching. There is an automatic failover setting in the cluster that a lot of people don't know about, and it's this screenshot right here. You can set the thresholds, and it defines how often you allow a failover to happen. What happens is, let's say that your maximum failover threshold for one period is 6 hours. If you fell over more than, one time that 6 hour period, it's going to leave your cluster in a really funky state. If you're doing OS patching and your plan is, okay, I'm gonna go patch the secondary, I'm gonna fail over within a couple of hours and then fail back over and patch it. No, this needs to be changed. Now, don't go and set it to 10 or anything ridiculous. The reason why you want to have it set to low and it's automatically set to low is because if you have flipping, you want to catch that. Where if it keeps on failing over, you want to catch that. This is going to make sure that you understand what is going on. So like if you have it to max failure period, specified period is like maybe once or twice in a 12-hour period or something, it's not going to kill you. But if it has a set to 10, I don't think that's a good idea. So that's going to help you monitor what's going on in your system, and it's going to help your cluster make better decisions. I think, in my opinion, just because I've gotten bit with that in the past too. I think it's important to set up monitoring tools and scripts to regularly check the health of your servers and your network connections. If problems are detected, like maybe you have failovers that are happening, or your network goes down, maybe getting alerted before your customers let you know is probably a good idea. You can use tools like the failover clustering manager. You can use external tools like VictorOps, SQL Sentry. I know that we have things going into SQL Sentry and it gives us alerts when we're seeing failovers so that we can be right on the ball. What is going on? Why did that server fail over at 7 o'clock or noon or whatever when it's not supposed to? There's VictorOps. VictorOps is an alerting service. They also work with Splunk. That's a good one. And then AppDynamics is another awesome one I like. I don't know if I mentioned Nagios again, or if I already mentioned, but that's another one. But if you don't have alerts set up in your system to let you know when things are going wrong, I would be looking at that like really like soon. That's going to be a problem. Testing. Oh, please do not go back to work and add a file share witness to your production environment immediately and say, Amy Abel said that we need to have an odd number of votes and we just need to set it up because this is going to prevent us from having split brain, and then have your entire production environment go down because you did not test in a lower environment. You need to set up all of these things that you're going to be doing to test your cluster, to help to prevent split brain. Any of these configurations that you're doing, they should be done in a lower environment. Stager dev should be taking the hit first. The other interesting thing is that I'm finding that not a lot of people test their disaster recovery options, and they really don't test they don't test failovers. They don't test whether the network goes down and what is going to happen. Even though they have, maybe they have a 5-node cluster environment or a 3-node cluster environment and it's all beefy and set up in AWS, a lot of them don't test that. And that should be another thing on your list, is that setting up, testing, simulations so that your environment is not blowing up like this picture. So remember, like, test everything that you're looking at doing today in a lower environment. The reason why? It's because when I was testing my scenario, I took down the entire dev environment. But it was dev, right? So that's why I'm saying that. Documentation and trainings. It's very important that you ensure that your team understands the concept of split brain and all of the scenarios and the specific configurations that you're putting in place to prevent them. Document the cluster configuration, procedures for handling these potential situations. And that's important because we run up against cost savings initiatives within our companies, right? It happens all the time. So let's say that you added a file share to prevent split brain in your environment because you're only using 2 nodes. And then all of a sudden, you know, a new manager comes in and says, we need to save $20,000 a month. Let's get rid of all the file shares. They're not even being used. Well, that's a problem because that $20,000 might be a large amount for someone, but it's also a large amount when your customers are not able to get their data for 2 days because everything kind of went wacky and all your databases went into data corruption mode. So, you know, documenting that is also going to prevent issues from happening. Keep your cluster environment up to date with the latest patches. You never know why a patch is happening. Regular maintenance can help address any issues, vulnerabilities that can contribute to split brain. So that's really important too. And then let's do some key considerations. Because of the fact that I know everybody's environment is going to be different. So when you're looking at your cluster and you're trying to prevent all of these things from happening, I'd probably think about factors such as like, how is your network topology designed? How is your geographic distribution? Where is your node placement? All of these are going to minimize the likelihood of network partitions. You know, you just need to look at everything because everybody's environment is going to be different. You know, I could probably say, hey, we run on a 4-node cluster or 5-node cluster. I could probably ask you guys and you would probably say, hey, I run on a 2-node cluster. I don't have a file share, or I run on a 3-node, you know, we have 2 in the cloud and 1 on-prem. It's all going to be based on what you are looking at. The biggest factors that I have come up against in this whole thing have been on this list. And so I was just going to list them just because of the fact that they were a lot of conversations that came up during this scenario. The first one was cost. Cost is going to be always the biggest factor. I hate to say it, it always is. And the reason why is because a good availability option and disaster recovery option always comes at a high cost. You'd be surprised how expensive it is just to add disaster recovery to your environment or adding an extra node, especially if you have 100 clusters that you're supporting. It gets expensive. Disk share will be more expensive than a file share because you're paying for storage. Adding a 3rd node will be more expensive than adding a file share because you're paying for an extra instance. You know, the other thing is like, what are your SLA agreements? Do you work for a bank? Do you work for a healthcare company? Both of those things are, you know, very important to look at when you're working for companies like that, because your SLA uptimes may be higher than other companies, which does come at a cost. And it also might be a selling point. Because if they're worried about their SLAs, they're probably not worried about spending that $20,000 extra a month. But anyway, what are your data recovery plans in case a failure does happen? Let's say half of your production environment goes down, you had split brain, and it made it so that half of your environment was not recoverable at some point. I don't want to scare you, but I'm just saying, what if, right? Let's say that you lost a bunch of data or your backups, or, you know, that you need to restore a backup. How much data are you okay losing? Are you okay with restoring everything. You know, is your company require the data to be available in 15 minutes, 4 hours, 24 hours? Is there a difference between your SLA and recovery objectives? You know, these are all things that you kind of need to think through, because if your SLA is that you have to have 99.9% uptime, and your recovery options are that you have to provide data within 15 minutes of being down, oh boy, yeah, I would definitely be looking at this. The other thing is that you need to look at your version of SQL Server and what it offers. Remember, 2008 may not be like 2022 or even 2012, because 2012 R2 is when the dynamic quorum witness came out. Do you have multi-region clusters? Is there going to be latency? Where are they based out of? You know, how does it perform? How is the network set up? All of those things need to be considered. And there's so many ways to set up an environment. So I kind of don't want to go into that, because I'm learning that everybody has a different way of doing it. The other thing is like, maybe you need to consider your owners in your cluster settings. Are you having a node be an owner when they're not even supposed to? You know, these are all things. And then remember, you're only allowed to have one file witness at a time. So if you go in and try to add a second one, it will take the other one offline. One thing at the top of my mind is, if you're using a file witness, oh, you need to have them communicate whenever they're doing anything with that file witness. Like if you have people that just go in and boot stuff all the time, and they're just going to go randomly mess with that file share and it's connected to your cluster, that might be a bad idea. You can obviously remove the file witness with the PowerShell script, so it's not that big of a deal. But if they're going to just go in and reboot things the same time that you're doing OS patching, you can lose your cluster. Like not lose it, but like it can go down and cause problems there too. So these are all factors to think about. Now, remember, no solution is completely foolproof, and split brain can happen despite having all of these precautions. Even if you designed it to be amazing, there's always going to have that like 0.1% or whatever it is, right? Okay, now part two. I kind of want to tell you what happened with the scenario of what happened with me and my work, and the reason why I found out that the cluster was kind of going crazy and it blew up. We found out a couple of things. One, we thought we were doing good because we had node majority votes, right? Because we had 3 nodes. And what happened is, and we've since fixed this obviously, but what happened is we found out that there's a couple of things. One, we weren't using one of the regions. We just had built it back then, and it was supposed to be used as a disaster recovery site, but it wasn't in use. It was set as an owner. That bit us. The second thing is that we needed to add a file share witness, because of the fact that if the three nodes go down, or let's say that one of the nodes go down, and you have 2 left, then you need to have an extra vote. And that adding that file witness in there added the stability that we needed, because anytime that we have, you know, any of those clusters going down, then we still have, you know, 2 or 3, whatever it is. It's always going to balance and give us a dynamic number. And I just looked at the time, Andy. I am sorry. I know that we don't have another presenter. I do have a little bit of a demo to do, but am I overstepping? I thought I was gonna like be short on time.
I say keep rocking and rolling, but Anthony and Andrew?
Yep.
100% keep going.
Okay, I am so sorry. I actually thought this was only going to be 15 minutes, but I'm a little bit of a talker. I'm sorry.
And you only wanted a 45-minute session.
I know, I signed up for 45 minutes and then I was like, I'm not going to have enough content, but this is a very passionate subject of mine. So I hope that you guys are all entertained at least.
Keep going. You're doing great.
So what we found is that there was, we had to add the file witness share, because we wanted to have a tiebreaker. We needed to remove the owner from the node that wasn't being used for our disaster recovery. We also needed to set the automatic to the region that wasn't really being used yet to be in manual, and that solved a lot of our problems. But the main thing is that we had to add a tiebreaker. Now, during that process, the reason why I say to test in development is because I did blow up development quite a bit when I was testing this, because I kind of wanted to figure out what would work best for our environment. And unfortunately, I can't say what is going to work best for each and every person in this call without really understanding how your environment works. But I will tell you, it's a balancing act. You kind of have to know, you kind of have to test. You have to take one cluster down, your file share down, you have to add your node. You have to do a lot of playing around to see what works best for you. So my final thoughts before my demo. Use a tiebreaker. Review your configurations. Set up monitoring if you don't already have monitoring set up. Please, if you do not have monitoring set up, like, that is so bad. We should know when our problems are going to happen before our clients do. Investigate the cost. Don't go to your boss and tell them that you need to have an odd number of votes because you're only using 2 clusters and you want to add a file share, unless you actually go back and tell them how much it's going to cost, what the benefits are, and so that they have a better idea, especially if you're going to add an extra instance. And then obviously review your budget with your boss or managers or whatever, because maybe you're saying we need to go the cheap way. Maybe we need to do like a disk instead. And maybe they do have the budget because of the SLAs and the recovery objectives that they have to carry. And that maybe they can give you more to build a more robust cluster to prevent that from happening. And then create the documentation so that later on, that they're like, oh, well, we need to just save money and remove all of this hardware or whatever that you're doing, so that you don't have that issue happen again. And then test all your scenarios and don't do it in production. That's just bad. I mean, it's scary too, right? Okay, so this is my demo, and it's just a small demo. I built this clustered environment, and it has domain controllers and everything. It's actually pretty cool. I hope you guys can see this. I blew up my screen a little bit better. So you can see here, I have 3 nodes, okay? Now, if you see assigned vote, it's 1, and then current vote is set to 1. I want to show you what happens when I add an even number of votes or nodes. And then I want to show you what happens when I don't. So right now it's an odd number of votes and everybody has a vote. It's looking really cool, right? If we go in and we query PowerShell, because you can do everything through PowerShell, it will say the same thing. Okay, the dynamic weight is 1 for everything. Now, I'm going to go in and I'm just going to add a note because I'm feeling really good about this. And I can also remove a node because this is my own little test environment. It's kind of cool. And I'm not going to require, now this is me doing things fast because obviously I don't want to spend an hour doing this, but I'm just going to say, I don't want to run any tests, but generally you would. And I'm just going to say, okay, add this to my cluster because I'm feeling pretty good. My boss just gave me a budget. He wrote me out a check for AWS and he said I can add as many as I want. So I'm going to go like crazy and add a fourth one in there. Okay, and then while that's being done, I want to show you a couple of settings to look at as far as preferred node and stuff that we talked about. If it will let me, it probably won't, but this only takes a minute. Oh, one more thing. This is my my favorite documentation to look at when I'm looking at this stuff. If you're looking at deploying a cloud witness and you want to find out, okay, what does it require? What are the prerequisites? What do I need? For instance, like if we go to a file share, and you know how I talked about how it has to have control, it has to have access to the cluster, it needs to have, you know, the 5 megabyte free space on there, it needs to be joined to the domain. This is documentation that you can go on and you can look through on the Windows Server documentation for Microsoft. And I've been noticing that they've been doing redoing a lot of their documentation, and I really love it. Okay, so that's done. I'm just going to click finish. Guess what happened? Dynamic node voter come in and said, you know what, Amy, we don't like that you have an even number of votes. So we are automatically going to remove one. So right now, even though the votes were there, it's saying that the current votes are only set to 3, and that's to offset it. Now what I'm going to do is I'm going to just say, okay, well, you know what? I'm just going to turn off that box. I don't want it on anymore. I'm just going to turn it off because I'm testing my DR, like I'm testing my configuration because my boss just gave me a really good budget. And so I want to make sure that this works because I'm in development, right? So now that it's going to turn off, we're going to see what happens. Okay, boom, dynamic quorum just stepped in and said, okay, you're offline. We can't access you. The other 3 can vote. And then if this one was primary, it would switch it to another node. Obviously, it would switch it to a couple of things. One, it would switch it to whatever preferred settings that you had. If you didn't have a preferred setting on, it would pick whatever the better option is. So like, for instance, if these 2 were set to be configured to an automatic failover, then it would possibly pick one of these. But if this one was not set and it was definitely not at that, then it would not pick that one. So that's what the dynamic quorum does. Now, if you're trying to configure these settings, I wanted to show you how to do that. If you go to, so this is my Amy trash box. This is my my cluster. I go to more actions. I can go to configure quorum. And this is telling it how you want to set up the voting. Remember, do not do this in production. And there are PowerShell scripts on this page on how to actually do it all through PowerShell. So if you have 100 clusters, don't do this manually. I'm just showing you for fun. But yeah, so you have your default configuration, you have your witness, and then you can have your advanced quorum setting. If you select this one where it says select the quorum witness, I have all of these awesome options here where I can select the disk witness, I can select the file share witness, I can select a cloud witness if you have that option available. And then if you say, I don't care if I have a quorum witness or not, you can select that. But then at the very end, it's going to say, this is probably not a good practice. I don't know if this is good, because it's going to give you a warning. And it's going to say, this cluster is not configured with a quorum witness, and the best practice is to have a witness to achieve the high availability of this cluster. So that's how you would look at changing the quorum configuration. And then one more thing I want to show you, because I thought it was awesome. Actually, two, sorry. So if we go here and you go to roles, you will click on this and you will have preferred owners. This right here, you can click on and you can make any of these a preferred owner like we talked about. And you also have your failover specified period. So now you don't have to log into each node and then change this, because remember, you're doing it for the entire cluster, which is kind of cool, because I failed mine over a few times and I was wondering why it didn't go crazy. I set it to 3. So this is another thing that you need to look at, especially if you have failed your cluster over more than one time in a 6-hour period. If you get a call and your cluster is completely hosed and something weird is going on with it, and then you find out like your operations center just failed it over multiple times, you may need to go in here and adjust it and then apply it, and then you can change it back in order to get your cluster working again. And then one more thing, if you go in here and you go to configuring your quorum, you go to advanced quorum settings, you can select your voting configuration based on what nodes you want to vote. So if you think you're going to be making better decisions by saying this guy doesn't need a vote, or maybe you don't need no nodes to vote, which, yeah, that's probably a bad idea, this is where you would do it. So anyway, that's how you would check that. And then there are options. I shouldn't be showing you this just because if you do this, I don't want you to blame me. But if you run this command, get cluster.dynamic quorum equals 0, this will turn off that dynamic quorum from making that decision. Now, you would change this to 1 or 0 or whatever, and that's going to change this. That's going to change that from happening. I don't know if I would recommend that. There's another option. If you go to, let's not remove the cluster. If you go to get cluster quorum and you do the FL, it will tell you what your quorum type is. So this is another cool option. But anyway, that's all I had today. And I'm sorry I went over. I kind of wasn't expecting that to happen. But now, if we have time, Andy, I don't know if we have time, but we can always have them post questions and see if I can answer them in the chat too. I'm good with that. Whatever you guys think.
So we do have one question in the Q&A. So should failback be set to allow failback or not? And what are your thoughts on that?
So it actually depends. I would say that it's going to depend on what your failback option is. So for instance, and I'm guessing that what you mean is that failback option on the screen. I'm thinking that you're meaning this one right here.
Yes, the question came up when you were in your demo.
Okay, perfect. So they're saying this right here, the failback. No, my preference would say no. However, my environment would not do well with this feature. And the reason why is because it just depends if you want it to automatically fail back to the preferred owner. Now, if that's going to work for you, yes, you can do that. Personally, I don't like this feature because of the fact that I want to understand what is going on with my cluster. And I also have more than 1 or 2 nodes, right? I have like, you know, if you have 3 or 4, this option is probably not going to be good for you because you have other options to fall back to. If so, anyway, it just depends on your setting, but I would say don't have that selected, in my personal opinion.
Cool. Got a couple more questions coming in on the Slack channel. How would one design or plan and test for 2 quorum nodes to go down simultaneously again?
Great question. I come at a cheap rate too. I'm just kidding. I can show you how to do that. I'm good at taking things down. Just kidding. No, so if you're wanting, okay, perfect question. I love this. What I did in my testing environment is okay, so first of all, if you go into your file permissions, if you're trying to test your file share to go down, okay, because I know that we're going to talk about like the nodes going down, but if you're wanting your file share to go down first, what you do, you click on it, you go into edit, and you deny all of the permissions so it doesn't have access to it for your file share. If you're wanting to stimulate what would happen if anything happened like that first. The second thing, and the reason why I'm mentioning this to you is because you said that you have 2 clusters. You definitely do need, in my opinion, a file share for a tiebreaker. Now, if you're trying to test 2 nodes go down at the same time, I'm assuming that you have more than 2 nodes. If you don't, your cluster is just going to die anyway. And anyway, what you would do is you could go into your settings, and it depends if you're in Hyper-V or if you're in AWS or whatever you're at. Because what I can do is I can turn off I can turn off where nothing can hit that IP or nothing can hit that network, basically. And so you'd want to do that in PowerShell some type of way. In Hyper-V, I can actually do that here, where I can go into settings and I can just make sure that it's not accessible. So basically you would want to just make sure what you're doing is essentially running a PowerShell script that hits it like that at the same time. Now, let me tell you, the reason why I'm not demoing Split Brain is because it's really hard to reproduce, which means that we hit the lottery when it happened to our environment. It was Vegas. Everything was lit up like a Christmas tree. And then the other option is you can have AWS have another outage, and that will cause it too. So, but yeah, I would say just go in and see what you can do to make sure that you can't get any traffic to that, but test it in development.
Cool. One more question as of right now, and feel free, if you have additional questions, please feel free to throw them into the Slack or into the Q&A in Zoom. So the question here is this: how can you narrow down the cause of a split brain situation after the incident? This person who's asking stated that they were trying to use things like the error log, the Windows event log, cluster logs, but even with those methods, they really couldn't determine the root cause the last time it happened to them. They believed it was most likely a brief network interruption, but they could not prove it. So they're looking for some guidance as to what can possibly also help to narrow down what the root cause might have been.
That's a hard one, because what happened with us is that we had a AWS network blip happen and during that time, and nothing was reported during that time. We put in a ticket to them and they're like, no, that didn't happen. But then later on that we found out that it did happen. And so I think going down the path that you're going down is correct. Like reading the error logs, reading, monitoring. This is great, because App Dynamics, if that was another way that we were able to find it, is because we seen that the network, if I remember right, went down all at the same time, and our monitoring tools caught it. our logs really didn't present it. And when we were pinging the listener, we were pinging the primaries, and we were looking at the clusters, we couldn't really figure out what the cause was. So I would say that it's hard because, even if you have concrete proof, finding the root cause is always going to be the hardest part. It's going to be digging and digging and digging. Now, at that point, if it's going to be harder to find the root cause, than you've already tried to do, the next step is, you know what? I'm just gonna move on, and I'm just gonna prevent it. Because if you're assuming that the network went down and you can't prove it, trust me, it might happen again, because that's actually what happened to us. That's what happened to us. It happened twice. It actually went down again. But the thing that we learned is that you have to spend the time to prevent it. So even if you can't prove it, you could say, okay, well, I think the network went down and that's what caused it. However, if it does go down, this will prevent it from happening again. And prevention is actually better than finding the root cause. I know it sounds crazy, but, and at that point, if you have prevented it and then it happens again, then maybe finding the root cause is going to be better. But it's time consuming.
All right. Outstanding. Well, it doesn't look like anything else is coming in on the chat or the Q&A. So Anthony and Andrew and Mark, I'm going to hand things back over to you to wrap things up.
Excellent work, Amy. That's a session that is so critical to any operational DBA that's been down that road. I've been down that road. I mean, so everybody raise your hand if you have before, right? So,
Thank you.
yeah. Thank you so much. Very well done.
Absolutely fantastic session. Thank you. Okay, can I grab the screen?
Yeah, you sure can.
Thank you.
Oh, there we go.
Just in case.
Every single time I'm in Teams, I'm looking there going, where? There we go. So we have, again, all our resources for you. We have the GitHub repo where we will get all of the speakers' sessions uploaded, and we will let you know once they're in there. Same with YouTube. The whole day will be up there pretty much immediately, and then we'll chop up the individual sessions and get those posted as well. We have our webpage, Twitter, our email. If you'd like to contact us directly, info@8kb.online. We've got the SQL community site. We've had a load of people hanging out in there today. It's been really good fun chatting with everyone. And then we have the feedback form. Please do leave feedback. And then finally, the store link there. This is a 100% funded by sales from our store. So if you'd like to pick up a hoodie or a t-shirt, please do. Every profit we make from selling those goes straight back into basically our Zoom license.
Every hoodie I've ever purchased from there gets stolen by my teenager.
So, as we said, for those of you who have just joined in the Slack channel, and seen a few new people jump in. Unfortunately, our Genesis had to cancel this session today, so this is the end of the event. But for everyone who's attended, we will be in contact soon. We will rearrange his session, and we will send out a link to the new Zoom session as soon as we get that sorted for you. So there is the link to the feedback. Please leave feedback for all the sessions, and please leave feedback for the overall event as well. We really want to know what you thought, what you liked, what you didn't like, so we can keep making this event better and better. So next year, and we will be back next year, we can put on as good as an event as possible. So the only thing left to do really is to say thank you. I want to thank all of our speakers. They have been absolutely fantastic. Claudio, Deborah, Jess, and Amy, for mind-melding, in-depth technical sessions. I actually, my my imposter syndrome kicks in like no tomorrow here, because I do a bit of presenting, and the standard of sessions we get here are so unbelievably high. The next time I do a webinar, I'm sitting there going, oh God, I'm not very good. So massive, massive thank you to them. Massive thank you to our moderators who have been helping out all day with the question Q&A in the session. So we've got Rob, Andy. Oh God, my mind is failing me now. Come on, who's the other one? Jess, the other Jess.
Jess.
There we go. So it's massive, massive thank you to them for helping out with the Q&A and just generally being awesome people. And then finally, thank you to all of you. Thank you for coming. We really, really hope you've enjoyed. I hope you get something out of these events, because otherwise it's just me, Andy, and Mark sitting in a Zoom session talking to each other, which isn't really that much fun.
Thanks.
Hi, Andy. Anthony, did you enjoy? That was pretty good. I think it's one of the best ones we've done.
Definitely one of the best ones we've done. I appreciate everyone coming and all the speakers and moderators. This helps really drive our community forward. So thank you so much for all of this.
As I said, we will be back. We will keep an eye on our webpage when we will announce when we've posted up all the YouTube videos. And we will be in contact about rearranging our Genesis session. So without further ado, goodbye and see you soon.
Thank you.